Welcome to the second day of Native Rejekts. I hope everybody comes with full energy after 1 hour more sleep, okay? So please welcome Tiffany. She will be talking about how to reduce our frustration, so that's a good plan for a Sunday morning. Over to you, Tiffany.
Thank you. Yeah, good morning. Even with the 1 hour of extra sleep, the jet lag is real. Thanks for actually showing up this early, because right now for me this feels very early, even though it says 9:30. So that is the talk title. It says 7, but because this lovely thing called inflation, and because I don't know how to guess how much time something actually takes, there's more than 7. If you use Twitter or X or whatever, my handle's there, and the rest of everything else is there. So this was actually created by Jerome Pedizzoni and me. He unfortunately lands at 7 p.m. and therefore I'm here by myself, because I also may have submitted for this talk at 2 a.m. in Hamburg and forgot to tell him that I submitted it. Whoops. So yeah, anyway, I am a developer advocate at VMware. You may have seen me at Intel or Docker or Amazon beforehand, and I do photography in my spare time. The QR code at the bottom of the page, assuming I didn't screw it up, is actually a link to these slides if you want to look at them afterward. I also learned a few minutes ago that part of the 30 minutes is 5 minutes for Q&A, so I might have to skip some slides depending on how things go. So yeah. Okay, so a lot of you probably have run on a local cluster of some sort instead of only in the cloud, especially since it doesn't end up costing extra money. So there's a bunch of different options here. There's things like Docker Desktop. You've probably heard of things like Kind, Minikube. There's OrbStack, which is what I'm running on my machine, since for whatever reason in the last couple weeks Docker Desktop stopped working for me. Who here has used at least one of these things? All right. If you didn't raise your hand, maybe you're new to Kubernetes or you're not listening to me, which is fine. Good morning. All right. So, okay. Did you know that if you're using Kind, that you can actually create a cluster that has multiple nodes? Cool. All right. I did not know this until pretty recently. So basically, you can just give it some sort of YAML file and actually go and do that. So I'm going to go actually create that. All right. So depending on how the internet goes, hopefully this doesn't end up taking forever, since I should theoretically have the image pulled. I may have tried doing this at the pizza place last night, and after 4 minutes, I still didn't have Nginx running. So we'll see how it goes. All right. So some reasons why you might want to do that is things like testing. Maybe you have some sort of daemon set that you want to be able to verify is actually properly running on a bunch of different nodes, or do I want to do something with some sort of node affinity or taints and tolerations? There's different things that you might want to test and be able to do that locally. Most of the time, if you just do Kind cluster create or use Docker Desktop, you probably end up having just one node. So who has heard of kubectl wait? Okay, I was just like, nobody? Okay. So you can do waiting on a bunch of different conditions. So for instance, you could do a kubectl wait for your nodes and wait for those to be ready. For some things, maybe you want to make sure that you have all your nodes up before having some sort of deployment. And maybe you don't want to end up having your deployment running all on the first 2 nodes that came up, for instance. So if we did a kubectl wait here, it's already up, so it's just going to go and say for each of them right now that the condition is met. Otherwise, it would wait for all of those to come up. And then you can do some sort of timeout. There is a default timeout, and then if you need it to be longer, and I'll go into that a little bit later. So yeah, basically just making sure everything is up before you start spinning things up, which is super useful if you're doing some sort of CI/CD type of testing stuff in general. Obviously, that may matter more if you're not just running it locally on a Kind cluster. Okay, so who has heard of kubectx or kubeNS? All right, cool. A decent number of people. If you haven't, basically, they are some tools that Ahmet Albakan created that basically allow you to easily switch between a context. So if you have one or multiple kubeconfig files, to be able to be hey, I want to switch between this cluster and this cluster. And then there's kubeNS. So instead of doing kubectl -n namespace a billion times, if you are doing a bunch of stuff in a specific namespace, you can just use kubeNS and switch namespaces and do everything within that namespace. So if I were to do create namespace hello, and then if I did kubeNS, I can actually see all the different namespaces that I already have running on this cluster. So there's all the default ones that I have, and then I can go and switch over to my hello. You can use like FZF, which is I have installed to be able to tab between them. Otherwise, you might have to actually type out whatever namespace it is instead of being able to scroll through them. And then if I were to do kubectx, for instance, we can see a bunch of different clusters that I have up and running at the moment. So I want to stay in my kind one. OK. And can everyone see the whole screen from even the back of the room? Because sometimes I learned the hard way that sometimes the bottom of the screen, you can't always see that. Actually, I'll just do clear for now anyway. OK, cool. All right. So like with being able to wait on nodes, you can do things like waiting on a deployment, for instance, for that to be up and ready. So if I were to go and create a deployment, OK, so then I can go create the deployment, and then I can do a wait on the deployment as well. And then, for instance, this one is super fast. When I was trying to do it yesterday, it just, 5 minutes later, it was still waiting on me and telling me, hey, there's nothing up there ready. Like if I did get deployments, we can see that it is true that it is up and ready. So basically, like you can do this with a bunch of different types of resources. So if we look at this next one, who here has done a -o JSON path? OK, cool. So if you haven't, basically it lets you like go through your JSON and pick a specific, like say for this one, you can go through items, status, and then get the different types of conditions. So based on that, you can figure out, like, hey, what are the types of conditions I can wait on for a specific resource? So if I go, oops. Oh my goodness, going the wrong way. OK. So if I did that, I can see that I can wait on both available and progressing. There's different ones for different types of resources. And so like, it doesn't always show all the conditions. Like for jobs, there's some things that don't specifically show up, and just making sure that hey, I can check for maybe a deployment. I can see what different things you can wait on. OK. So then you can also do this thing for services as well. So like I could go and expose the deployment, and then you can actually wait for endpoints. As of a pretty recent version of Kubernetes, you can do this --4 and then give it JSON path. And then you can actually, instead of having to go and be like, find wherever .ip is, you can actually do .ip, and it'll go and find that for you. So if I go and do expose, so I can expose that, so then I can wait for endpoints. And then it's already up because this internet likes me a lot better. So basically, you can just do things like that with it. There is also the ability to do that if you have if you decided, hey, I'm going to do a type load balancer. So basically, you can wait for the endpoints to be up, but then also you can specifically go with the service to be able to see that there is the external IP is up, and that you can actually that actually has one that you can go to look at afterward. So the default timeout is 30 seconds for kubectl wait. Some things might take longer than that, so you might want to do something like earlier where I had the wait for like 10 minutes, for instance. You could also set it to 0, which basically just checks once and then reports whatever that status is. You could do a negative value, which is, I guess, longest time, which is a week. I don't know what you're doing if you're waiting a week, but if you are, let me know. I'm curious. And then you can also do like a kubectl wait for and then delete as well. OK. So there's a couple things here where it's like, oh, I added it later, and I added a half, because changing all of the numbers is kind of a lot. So there's also a tool called CAP, which is part of the Carvel tool suite. If you saw Whitney and Victor's talk yesterday, there was mention of that. So basically, it kind of acts in a way of like having the kubectl wait. So you do a cap deploy, and you give it some sort of name. So like I am calling my app hello, and I give it a YAML, which just has a deployment there basically. But it'll wait for every single resource type that is there, and it'll actually start printing out things telling you what is being created. If you go and do a cap deploy on something that you're changing, it'll actually tell you that things are being changed. So if I actually tried just doing that here, and you can also see that since I didn't give it a -y, it is asking me if I want to continue. But like you can actually see like what is being created. I already have the deployment, so that's not going to work so great right now. So I'm not going to actually continue with that. But basically, it'll actually spit out each thing as it's creating it. And then there's a bunch of other tools that are there as well. So like there's YTT for YAML templating and a bunch of other stuff. So if you want to look at the other things, you can go to carvel.dev. OK. So deployments. Turning a deployment on and off again. Have you literally tried turning it on and off again? It sometimes fixes things. So one way to go about doing that is to do a kubectl rollout restart and on the deployment. So basically, what it ends up doing is it just ends up adding an annotation. And then based on that, it will trigger a rolling update. So if I did a kubectl rollout, if I do that, we can see that it was restarted. And then if I did a git deployment, let's see. And I'm really bad at typing when I'm nervous, so let's see if this worked out. All right, cool. It worked. So yeah, it said that it was restarted, and it is, yes, it is November 5th and 9:41. So yay, that just happened. OK, cool. So and also if we end up getting deployment here, we can see like just a bunch of different things with that as well. All right, so basically that's one way of going about doing it. If you actually want to completely turn it off and then turn it on again, one thing you do is you can actually scale to 0. Who knew that you can scale deployments to 0? Most everyone. OK, cool. So I'm glad you're all learning something new, since you already know everything anyway. Who wants to do my talk for me? But yeah, so basically you can scale it to 0, where it's not just having where you're rolling out a new one immediately afterward, and then you can go and scale that back to 1 whenever you decide to. One of the times this is super useful is, say, if you're using some sort of cloud provider for Kubernetes and it's caring about how many pods you have running. All right. But why though? So some reasons are that you might, again, want to turn off things that aren't in use, but you don't want to completely go and just like remove every single deployment that you maybe need to run in like a week or whatever. Maybe you want to do something with some sort of auto-scaling. There's some things like with auto-scaling that it might rely on like CPU utilization, for instance. And it's a little more complicated if you were dealing with front ends, but there's a bunch of different things there. There's also a tool called Kata that you can go and look into as well. OK, so who knew that you can connect to a service within a different namespace without having to have some sort of like load balancer or something like that? OK, nobody knows what I'm talking about. Cool. OK, so basically, say if I were to just go create some sort of namespace, and so if I were to create this deployment here, and I expose it, I can basically use external name to go and have it be the, so yellow is the one that I'm exposing here, and then blue is with the namespace, and then you give it .service.cluster.local. And then you can end up having it where you just, like for instance, if I did a run test and I could attach it, and then I could end up using that service external name that I have here. All right, I don't think I can actually have this working on the cluster that I currently have set up because of just how it works. But later I can try showing that on a different cluster if there's time, which I don't think I will. But this is a thing, slides, you can try it later. All right, so generating a YAML manifest. So a lot of the time when I was first trying to do this, I would be like, oh, hey, let me go to the docs and go and copy paste something, and then I'll modify it, or go to some website, or I guess now everyone's using ChatGPT and be like, hey, create a YAML manifest that does this thing for me. Some of that stuff works if, say, if you're working on like the CCAD or CKA or whatever. But like, for instance, for the CCAD, when I took that, you could use Kubernetes docs and nothing else. But again, going and searching, which I may have done, takes a little bit too much time. So there is actually a way where you can just go and just do as you normally would with creating whatever resource that is. Give it like -o YAML if you want the YAML, and then you can give it a -- dry run client, and basically that will end up giving you YAML. So apparently I like going through slides a little too fast, but if I were to do deployment, you can basically see, and if I did it with this tool called like I can make it pretty because sometimes people like color, some people hate it, I don't know. But basically you can see that it's created the YAML, and based on that you could add things like, for instance, with some of the role bindings, there are certain things you can't do with flags, and then therefore you might just create a base one and then make some changes afterward. All right, so then who has heard of kubectl patch? Okay. This is a lot. Okay, everyone, I like you all. You all know a bunch of stuff.
I mean, I've heard of it, but I haven't used it.
Okay, all right. Maybe I should just do that instead. Who has actually used X thing for each thing? All right, quick. Who's used kubectl patch? Okay, that's a lot less. All right. Thank you for my new question. All right, so basically you can patch to make some changes in what, instead of having to necessarily do like a kubectl edit and then scroll through for trying to edit some specific thing. So right now we have my deployment, which, as you probably saw, is just running a regular Nginx image. If I were, for instance, I could be like, hey, maybe I want to try changing the name and like my image to Nginx Alpine because Nginx maybe takes too long to set up or something like that. So let's see what happens when we go and try doing this. Okay, so if I do that, I can actually run K9S, assuming it likes me. And who has tried K9S or heard of that? Okay, cool. So for those who haven't, basically it's a prettier version of running through your terminal to be able to see what is happening. Basically, you can actually like go through it and watch it as things are changing. For instance, for a second I looked at different ones and it's doing different things. But basically, you can see if there's like an error happening. You can see things coming up and running. This one is going to give an error based on the fact that if we look inside, what actually happened with my patch is it has my initial one and it created another one, and it's going to fail because they're both trying to use port 80. So for instance, depending on what you're trying to do with the patch, you have to be careful as to making sure that it's actually doing what you want it to do, because this obviously is not what I wanted.
That's been my experience with patch as well. It works for some things, and other things it like destroys your YAML.
Yeah, so not the best necessarily, depending on what you're trying to do. So if you did what I just did and didn't want something, you can actually do a patch to be able to go and remove. For instance, I want to remove the container that I just ended up adding to it. As far as I'm aware, I don't know how to actually select by like array item by like the value of being like, hey, I want the smaller one to go away. If there is one, come talk to me later and tell me how to do it, because that'd be cool. So if I were to go and actually go patch it again, okay, so if I were to like look at K9S again, we can see that it's back to having one. Okay. So then you can also do things like you can decide, hey, I want to actually see specific column names of, like, say I want to see the architecture, I want an instance type. You can decide based on like what you actually care about seeing for column names and just having those specific things show up. So like, for instance, this might be useful if you're like, hey, I want to see what different instance types I have, and there's the two different ones. For mine, they're all, it's not really going to show anything. They're all going to be the same because it's running on my kind cluster. Hi.
Can I rename columns?
Can you rename what?
Can I rename columns? Like if I want to rename instance type to something else?
You can. It's a little complicated. Again. And you would have to use either the Go template or the JSON path template.
Well, that sounds like work.
Yeah, but you just make a shell script for it, and then you never have to do it again. Wait, please small shell script.
All right, and then you can do things like checking which controllers actually own the pods. So for instance, if I were to do this, let's see. So I can go through and see everything that I have up, and then you can actually see, hey, like for hello, for instance, it's owned by replica set, and just like what the different things are that own it.
You were ahead of you had.
Okay, so instead of what I did with the patch, you can actually use kubectl_set. Who has used kubectl_set? Okay, cool. This is a better question. I like this. Actually, who's heard of kubectl_set? Okay, no, this isn't just a better question. Just the answer is no one. All right, except for 2 people. Cool. All right, so basically what I can do is I can use kubectl_set to change different things. So I can change like what my image is. I can set whatever service count is. You have to be careful with some of these because you can do like --all, for instance. If I did it for all on my service count for a service count that doesn't exist, then now I just kind of made it so that all my stuff starts failing. So you have to be careful. And then, so like for instance, if we did a set image, so if I did kget deployment, we can see that it's now Nginx Alpine. Yes?
Where do you get the list of attributes you can say for each object?
So that is an excellent question. I don't actually know.
Isn't there an explain command?
There is an explain, but I don't know. I don't know if you can do it for every single thing. And then it was -r.
Dash recursive.
Yeah, I couldn't remember if it was -r for cursive because every tool is different. But I don't know if you can do it for literally everything or not. But if you want to see every single possible thing that there is there for something, you could. But
it depends on how well
I'm not
the
sure.
people that worked on that section documented using OpenAPI. Because you can specifically request like one field, and it should give you a description and possible values. But not everybody documented their OpenAPI as well as others.
That got me through my CKA exam.
It's good. It's a good, really useful tool.
But yeah, so if you haven't seen kubectl explain, ta-da! Thanks for adding to my slides. All right. So yeah, there's some things that don't work. Like so, the --s selector doesn't work for everything. So for instance, you can't use that for a service count. It's a little complicated. All right. So then there's also kubectl auth, CANI, and --list. Who has heard of this one? Okay. So yeah, basically, if you decide to give someone RBAC permissions, it's kind of important to make sure that you actually gave them the right permissions. You don't want to accidentally have given them full access to your entire cluster, for instance. I mean, it's a little bad if you just didn't give them the access they needed, then they might be annoyed at you, but could be worse. But yeah, if you're admin, you can also check someone else's as well, and just basically use that. And there's several other plugin tools that are out there as well that you can add for also dealing with checking these types of things. All right, so there is a different, you can use a --s watch and then actually do output watch events, and it gives you a bunch more information. So like if I did, okay, so then basically, like if I was doing a bunch, like starting a bunch of different stuff, you can just see a bunch of the information as it's going through and doing that, and it waits on them. And obviously, I'm not setting up anything right now, so there's nothing new showing up. Super useful. Okay. So then, who has used? Actually, we're just going to go with heard of on this one. Who's heard of Gron? Nobody. Okay. I'm doing something right. Okay, so basically you can use Gron to see a bunch of what the path of something is. So for instance, I can actually see like JSON item status conditions and actually like that's memory pressure and just like go through a bunch of the different things there based on whatever you are specifically searching up. So if I were to try doing that, assuming I actually installed Chrome. Yeah, okay, so mine has a bunch more, and then based on whatever thing you have, you can use that for it. Okay. So who here has heard of Nixer? Okay, cool. I'm enjoying the seeing one hand raised thing. This is a lot better. All right, so basically say if you, maybe before you would have like some sort of Docker file and be like, okay, I'm going to go and start with whatever base image that I want, but I need, oh no, I don't have curl, or maybe you're like, okay, which specific Docker image for Ubuntu or whatever has curl and has my other thing, or you have to install it and it's just kind of chaotic and annoying sometimes. You can actually use Nixer for basically what this thing is doing is it is doing a Docker run, pulling down an image that actually has everything that you have between these slashes. It will have in that image, assuming that it's something that they actually have. So for instance, this one will have shell, Terraform, kubectl, Helm, curl, and ffmpeg. So basically the image just gets created on the fly, which is super useful, and then you have it all in there, which curl was probably the one that I needed the most. So there's a few caveats. So like images are AMD 64 by default. You can get an ARM 64 image by adding ARM 64 at the front. It's just more of the slash things. And then, but there's not any multi-architecture image yet. So since I was told there was supposed to be time for questions, here's the end.
Thank you so much. Questions for Tiffany? Buddy, come on. Okay.
Uh-oh. Uh-oh.
Okay, so a quick one. Way back when you were showing the JSON path that you had some expression that you were looking for IP. Oh, it was when you were doing the weights. And you had an expression that ended in IP. Dot IP, that's it right there. Mm-hmm. Does that look specifically for a JSON path that ends in the key IP or any path that has the key IP in it?
It looks for something that is just IP.
Okay, so yeah.
It's not like, if something else had blah, blah, blah IP and the IP is at the end of it, it's not going to have that.
But like if there was like .IP something else, would that show up too or no?
Let's see. I don't actually know the complete
I think
path.
according to the JSON path standard, if you put .star after it, it will show you everything under that key.
Okay.
So we tried it with, so I guess if you wanted something like, you mean like, for instance, addresses.ip or IP.
Do the
target ref.kind, yep.
Yeah.
Yeah.
I think if you do .star, it should give you all of them according to
Okay.
JSON path standard. So just replace kind with star.
Oh, that's what.
No?
Oh, interesting.
Or at least ZSH doesn't like it.
So then my other question was about Nixer. Is it possible to specify specific versions of things?
That one I don't know. I've never tried it with any specific versions. So I don't know.
I'll have to look it up in their docs.
Let me know.
Oh, so it looks like it would have worked if you weren't doing
This.
A wait for endpoints.
Yeah. Let's see.
So if you'd just done like a get or something.
Don't know if I need. Yeah, because it'd be. I don't know what specifically is the -4, and it would
Anyway,
have to be
JSON path. Learn it. It's good.
Like a full-on JSON path thing, not a for. Yep.
Okay, anyone
-O,
else?
all that.
Okay, then thank you so much, Tiffany.
Thank you.
Yeah, great. about configuration policies and how DevOps relate to all of them. So please welcome Courtney.
Hello. I was totally expecting this room to empty out and not have everybody here after the last talk. She was so fantastic. So thank you so much for joining me today to talk about how you can unlock collaboration through leveraging policies and guardrails in your Kubernetes deployments. I was supposed to be with a co-host today, so before we dive in, my name's Courtney Nickerson. I'm obviously the Calvin of this presentation. My Hobbs, I swear he's not a figment of my imagination. Ole Lensmar, our CTO, does exist. Unfortunately, his flight got delayed and then canceled and then delayed again, and so he's not going to make it in until this afternoon. Which means that there have been quite a few changes and adjustments at the very last minute to this. So if at some point in time I am staring at my screen or my mind goes blank, that was not my slide to present. So bear with me, but I really do appreciate your patience. So today we're going to be covering quite a few things. But some background on why we're having this. With soaring adoption of Kubernetes, obviously, there's loads of different situations that are happening now for DevOps teams. DevOps landscape is drastically changing, and really struggling sometimes in order to scale as we move into scaling our deployments to pods and clusters. There's loads of different challenges that have now presented themselves that teams kind of have to be able to attack as they're moving into this new cloud native era. And that's kind of pushed DevOps into a new adolescence. It's a little bit difficult to handle for some teams as they start to adopt Kubernetes. For other teams, they've been able to make the step into Kubernetes, but then there's constantly a gap that's growing between their development team, their operations team, and sometimes it's really hard to get those teams to collaborate and bridge those gaps. So all of this has also given opportunities for new roles to arise. We now have SREs, platform engineers. We have new types of technology as well. So platform as a service is something that we're going to be hearing loads about this next week. But it doesn't change the fact that there's still a persistent issue with trying to actually bridge the communication gap and the working gap between development teams and operations. So today we're going to take a little bit of a look at different things that we can do to leverage policies and guardrails to actually become the common language among teams as they're trying to learn how to collaborate in a much more scaled environment. We will identify and discuss some of the main challenges that teams are facing as they scale their DevOps culture. Oh, sorry. Not sure what I didn't mean to do that. We will share how to implement different policies and guardrails. We'll have a brief overview of what policies are and policy frameworks and the tooling in this ecosystem, because it turns out some people are using policies a lot, other teams aren't using them quite so much. So we'll have a brief overview of that, and then we will look at how teamwork can actually make the dream work and make your deployments better. So let's take a look at the actual challenges and gaps that occur when people are trying to adopt Kubernetes and scale their DevOps workflows and culture. So kind of since the inception of DevOps, it's kind of been a contentious definition of what it actually is, very multifaceted. Is it a culture? Is it somebody's actual role? Is it an engineer? Is it a defined set of workflows? It could be any of those things. But whatever your answer is, what's remarkable about DevOps is that it continues to remain very timely and in high demand. And a lot of that has to do with just the amount of potential business value that it actually provides for teams when executed well. But it doesn't change the fact that scaling something that is still difficult to define, whether it's a culture or a workflow or both of those things, becomes incredibly difficult. For one, DevOps teams rely very heavily on the tooling that they're using. And so finding ways to integrate and automate the usage of the right tools for your team becomes very difficult as you're trying to make this leap. Obviously, standardizing those tools is difficult, but even more important and almost just as critical is standardizing the processes and the practices that your team is actually using across different teams and cross-functional teams. In order to be able to leverage the advantages that those toolings actually provide. And that doesn't even start to talk about how difficult it is to uphold consistency as you're actually going through all of this across the board. And managing security and compliance could be a whole talk on its own. This has always been something that's kind of been left to the end. Nobody's super passionate about it except for the few of us that are. Everybody thinks it's a very boring topic. Today, hopefully, by the end of this talk, you won't find it quite as boring. It is pretty useful, but the reality is that it could be a talk all on its own. It's a very complex thing in order to do, and so when we scale to Kubernetes, those challenges scale also. But those are just tools and workflows and processes that we're talking about scaling. The thing that's actually really difficult to scale is the DevOps culture. So finding ways for people to be able to communicate with each other, to collaborate with each other, to make those workflows more efficient and effective, to adapt the practices that they're doing to an entirely new environment that they actually need to learn quite a few things. There's a huge learning curve for so many people. And in order to be able to bridge that gap, things can get very difficult. And on top of it, you're never going to find two DevOps workflows that are the same or two DevOps cultures that are the same. Between the industry changing, the resource constraints, and that could be constraints on budget or human restraints, right? Your human resources, knowledge gaps, not having enough talent on your team and just not being able to find enough people to deal with what you need to deal with. Your tech stack, all of those things make every single DevOps pipeline very unique and also very difficult with its own challenges to actually scale it. Unfortunately, as well, siloed teams and siloed workflows are still very much a thing. They're very prominent, and it happens to everyone. Even the best of DevOps cultures have moments in time where they have siloed workflows going on. And so when we scale to Kubernetes, that gap that exists in communication between teams actually continues to broaden. So we have to find a way to be able to bridge the gap that's already there in existence from before we scale, and so that it doesn't continue to get bigger and bigger. And so that's kind of where policies and guardrails come into the mix. We just described a bunch of challenges that people have, but the one thing that all of those challenges have in common is that in order to be able to have success and a success rate in terms of adopting Kubernetes and scaling it, you have to find ways for your human team members to collaborate and connect with each other. There's no other way to do it, and that really is the commonality between all of the different complexities that you have in scaling your DevOps pipeline. So introducing robust policies and guardrails into your pipeline plays a critical role in fostering a culture of collaboration and unity across your teams, because policies very much become a contract between your teams. They establish clear guidelines, they standardize your practices, they provide a common ground for people to actually find a way to transcend what are usually their boundaries and their siloed workflows, and decide that they're going to be able to collaborate because they're all working for the same objective. They all now have rules that have been set that they need to follow. So when you're leveraging policies with a purpose, they actually help to foster and culture a collaborative and responsible environment among your team. Also, it's a way to empower absolutely everyone. And while that might sound silly at times, the truth is a lot of times when you have complications that are going on in your team, it's because people don't feel empowered and they don't feel like they're being listened to, or they don't feel like anybody really understands the value of the work that they're doing. So in using policies and involving everyone across your team in terms of helping to define the different things that need to be done in each workflow, you're actually finding ways to empower your your devs team, your operations team, your SREs, your platform engineers, and that actually cultivates a whole sense of empathy because people start to understand what other people's challenges are in other departments. They're much more willing to abide by the rules that have been placed there, as well as speak up about their own needs. So that's kind of the reason that you might want to go ahead and involve policies and guardrails in your DevOps pipeline. Let me see. Oh, it just froze. There we go. So planning to build the bridge to bridge that gap is a bit more complicated. We're going to start off with just a very brief overview. How many of you are using policies and guardrails at this point in time? Oh, so you do all think it's super boring and useless. Fantastic.
I don't know what to do.
Right? We'll talk about it. We're getting there, building up the suspense. So policies very much, in Kubernetes, YAML serves as a framework to define your desired state of your clusters, your applications, your networks. And Kubernetes policies are very much guiding rules in order to make sure that the creation of all of those things is done correctly and securely, and you have all of your compliance, which compliance is boring. You didn't hear it from me, but compliance is boring. But all of these policies can be classified in different ways. We have configuration policies. They very much deal with just about anything that you could possibly have to configure, from security, resource allocations, best practices, naming conventions, labeling conventions, all of those things. If you need to configure it, you can create a policy for it. And then the other side of policies are runtime policies, and those very much are policies that govern security and access control, actually operative in your cluster. That's a very brief overview of how policies are, of what policies actually are. And integrating them obviously helps you be compliant, but a whole lot more efficient across the board. So how are policies defined? Well, there's a few ways of defining policies. Very quickly, policies can be defined by declarative and imperative approaches. YAML is oftentimes the main language, but it doesn't always have to be. Declarative policies, specifically tools like Kyvorno, use declarative policies and YAML configurations and based rules in order to enforce your policies in your cluster. There are also imperative policies, and those are those need other types of languages in order to write them. So anything from YAML to Cell, which is a common, common expression language, excuse me, and Cell policies have just now been included in the latest version of Kubernetes. So if you haven't started with policies, that's a very good place to start. But they're very easy to write and get started with. You can use loads of other languages as well, to TypeScript, to Go, kind of adapt to what you need. But additionally, by specification, so Kubernetes pod security standards, they're also a fantastic place to start. They're very simple and straightforward. You categorize the things that you need by privileged, baseline, and restricted. And then basically, when you run that, it allows your application any combination of those standards to actually have specific security that's needed. Applying policies to your YAML, when should you do this? Well, there are loads of different policy enforcement points across the policy enforcement pipeline. You can do this in your pre-commit phase, in a pre-merge phase. You can do it when you deploy, which very much, if any of you are Kyvorno or OPA Gatekeeper users, that's probably when you're doing it. That's the most common practice. It's fantastic. It serves as a fantastic safety net to make sure to see what has slipped through into your cluster. You can also do it in runtime. But whenever you do it, you should be doing this. So applying them earlier is better. We hear this every time we hear anything about DevSecOps or security in general. Obviously, if you are just starting to adopt Kubernetes, if you build policies and guardrails into that adoption plan, it's a much easier lift once you get started because they're already there. However, you can't always build everything in super early, and you can't always apply policies through pre-commit and pre-merge phases. Sometimes you're going to have things that you're going to have to look at in runtime. And so applying policies as early as possible obviously saves you a lot of time in some instances, but it's not always going to be possible, which is why you should always be using your safety net of running an admission policy, an admission control policy for your misconfigurations that might have passed through. On a personal note, shift left. This is very much something that irks me a little bit. So everybody in security is always talking about shifting left, and that creates a terrible developer experience just by saying it, because developers already have loads of things to do, and so as soon as you say, oh, we need to shift this left, they're automatically thinking, I already have so much going on. What do you mean shifting left? And specifically using policies and guardrails as a way to shift left, but also shift right. It's a way of including everybody, but also sharing the responsibility of security across teams. And that is incredibly important and crucial to do if you want to actually be able to not only scale your DevOps workflows and culture, but also get to a point where you have high quality deployments across the board. So it's one of those things, communication and culture are key. If you're saying to your dev team, we're going to shift everything left, they're going to stop listening to you. But if you say, we're going to have policies and guardrails in the pre-commit phase, and some of those are going to be for developers, our ops team is also going to be doing these things, our SRE team is also going to be employing these rules. All of a sudden, the responsibility is shared across the board. It's a much better experience for everyone, and everyone feels seen and included. So also, it's not all about policies, guardrails as well. It's included in the title, so we'll have a quick moment. Guardrails are also super important. They're a diverse set of approaches that teams can use to employ and ensure the development and the deployment of their applications is actually compliant. And they're very easy to put in when you're talking about scaling things. These approaches include implementation from anything like configuration policies, which we were talking about earlier, to leveraging YAML configuration templating, also using tools like Helm and Customize in order to make sure you have an effective management of your configurations. Are people here using Helm and Customize to package your? Great. So those are also ways, especially using dry runs, to be able to see the configurations or misconfigurations of your policies. But successful implementation of these guardrails ensures that there's a cohesive and collaborative approach to building and deploying your applications. So building the bridge, teamwork makes the dream work. It's always the case, isn't it? In order to get something done, you need all of your team to be on board. It really is a all hands on deck type of thing. However, there are some hands-on things that you can do to get started. So talking about where to get started. Admission validation policies, which are now active in version 128 of Kubernetes, great place to get started. Pod security standards, great place to get started. But even better than that is to take a step back and talk to your team and get everyone involved. That ensures that there's a shared understanding of the actual needs that not just one team has or just the entire workflow has, but that everybody has. A lot of times around policies, it seems really boring. We're back to the boring part. But also, a lot of times it's because teams don't really understand how they're going to be leveraged. Having a set of rules actually makes the developer experience much better, because then they know exactly what to focus on. They know where they should be putting their efforts. They know that they're not going to misconfigure something that then when put into production is going to cause issues and problems for other people, because some amount of rule has been established that lets them do their work a lot easier, a lot more efficiently, and with a lot more calm. So getting everyone involved, super important, so that they all understand the needs, the requirements, and the constraints that each different team has. The next thing to do is don't wait, right? So back to the whole, if you're adopting Kubernetes, this is something that if you build your policies and guardrails in, you're actually going to be building that bridge to bridge the gap of communication among your teams as you're adopting your policies, so that the gap of communication doesn't continue to grow and your bridge doesn't have to be anywhere near as large because you started to build it sooner. But obviously, there are so many of us here that have already adopted Kubernetes and haven't actually employed policies, which when we asked, we saw very few hands go up. But that's fine. There are loads of different ways and tools in order to get started in employing policies and guardrails. The important thing is to get started. The sooner you get started, even if it's a bit of an effort at first, you're still going to reap the benefits massively in the end. Next thing, aim high, but start small. You don't have to do it all at once. Start with something simple that is actually attainable, that different teams can collaborate on, so then everybody sees the value in it. Once they see the value in a small thing, all of a sudden that in itself is a lot easier to scale because people understand why you're doing it. And then make it something that is interactive among teams. Make your dev teams collaborate with your ops teams to understand the different issues that each one is having. Make your SREs talk to your QA team, because how often does that actually happen? But in doing so, you're actually bridging the knowledge gap that happens a lot of times, which actually is what makes your deployments more difficult to handle. It's the reason you have so many misconfigurations to start off with, because people don't always understand what needs to be done. And then finally, designate a policy leader. It sounds silly, but the reality is there will be somebody on your team who, like myself, thinks that policy is super exciting and really helpful. So designate that person, talk to your team, find out who they are, and designate them as the policy lead, because in doing so, your policies will actually move forward. They will figure out, hey, look, this is a super easy way to implement pod security standards. Let's go ahead and try it. They can talk to different people and they can get that started. Oftentimes it's going to be a platform engineer, but not everybody has a platform engineer to be doing this. So talk to your team, see who's interested, and get them started on it. And finally, crossing the policy bridge. So successful crossing of the policy bridge serves as a testament to the transformative power of actually focusing on helping your team collaborate and find mutual understanding, because that's what policies actually do. They become the common language for people to be able to understand each other and their workflow pipelines. So using policies to emphasize shared responsibility, facilitate open communication, actually helps to transcend those siloed workflows that usually happen. It builds empathy within a team, and so the integration of policies and guardrails doesn't just streamline your operations. It doesn't just get you up to compliance or optimize your developer experience. It actually strengthens the human bonds that are going on. It teaches people much more about the environment that they're actually working in so that they can be more successful. And above all, it makes for a much happier and productive DevOps team. So on that note, if you'd like to hear more about this or learn about open source tooling that can get you from code to cluster with policy and guardrail implementation, and you're here this week, please stop by our Monocle team booth, P35. I will be there. You'll get to see that Ole is not a figment of my imagination like Hobbs, because he will be there as well. And if you're not here at KubeCon this week, or you don't have time because there's so many other things going on, feel free to reach out individually at any point in time, and we can have a chat. Thank you.
Question for Courtney? Okay.
So you talked about, you outlined the needs for policies, and then, we talked about, you gave us some good insights on the implementation. Can you tell us about what that process looks like when you get your teams together and you're saying, we have this need, and how do you take that idea of the need in that discussion and turn it and architect that and roadmap into that before it ever goes into actual implementation, so that the collaborative process and identifying needs and then finding out like this need can be addressed doing this policy that way. Can you talk to us about that process a little bit?
Yeah, there are loads of different ways to get started with it. I think one of the most straightforward ways is, especially if you already have siloed teams, is directly ask each team, what are the issues that you're having? What misconfigurations are constantly popping up? What's taking up a ton of your time? Get those lists from people and then compare them. Because the truth is, all of DevOps is a cross-functional workflow. And so some of those things are going to actually cross teams, right? And so get those lists first and compare them, see what's connected, connect the dots there, and then you take the things that are common issues for everyone, and then you get a team together and you say, okay, look, this is actually common for everybody. How does it affect you in development? How does it affect you in pre-deployment? How does it affect you as an SRE moving forward? And then establish your policies from there. There are loads of policies that are already out there created. Kyvorno maintains like 200 and some odd policies for their policy admission controller. But there are also tools like Monocle that help you actually establish those rules beforehand. So if you're not really sure where to start, ask your teams first, what are the misconfigurations that you're having constantly? What's taking up your time? What are the things that if you could troubleshoot them very quickly that you'd like to do? Compare those lists and then get started with creating very simple policies to take that forward first.
Okay, any more questions? Okay, then, thank you so much.
Thank you.
Be back in 5 minutes. everyone. Please welcome Alex and Reese, and they will be talking about open telemetry. So over to you guys.
Thank you. Hello? We haven't started. Maybe hold off until we start. Just in case. Good. Okay. Good morning and welcome. So my esteemed co-presenter over here, Alex Bowen, realized that there wasn't a single place you could go to reference tools that are useful for any stage, let alone all stages of your OpenTelemetry journey. So we are very excited to put this together for you. OpenTelemetry Toolbox, tools you should never leave the house without. Yay. So with that context in mind, how we've laid out our session is starting at the very beginning, where you're just trying out OpenTelemetry, to instrumenting your own application in a local dev environment, to sending that data somewhere, and then finally, to deploying it in production. So before we get started, we wanted to do a quick survey, just a round of hands. How many people here are familiar or have heard of OpenTelemetry? Oh, okay. How many of you have tried it? Oh, okay. How many of you are running it in production? Oh, damn. Okay. Well. For those of you less familiar with, we'll just do a quick refresher on what is OpenTelemetry. So OpenTelemetry is an open source observability framework. Observability. It comes with a set of language-specific APIs, SDKs, instrumentation libraries, and tools that you can use. It aims to standardize how applications are instrumented and how telemetry is generated, collected, and transmitted. It's also a community. It's made up of multiple special interest groups, working groups, a technical committee, a governance committee, as well as, of course, our end users. And of course, for those of you who already use it, you know that allows you to be vendor agnostic. You can instrument your applications once and send your data to any backend or backends of your choice. OpenTelemetry is not a data visualization tool. It doesn't include things such as alerts. It doesn't store your data. So you still need to send that data somewhere to analyze it. Oh, I already said that. So, as promised, we're going to start at the very beginner stage where you're trying out OpenTelemetry. And, we guess you probably want something that's easy to set up and that allows you to quickly see some OTel data. The first tool we're going to talk about is OTel CLI. Since so many of you have already tried OpenTelemetry, you may already have heard of this tool. It is a command line interface tool that allows you to send traces to a collector from the command line. And if you're not sure what a collector is, Alex is going to go over that more in depth later on. I know he is so antsy to tell you about it. So this is a good tool for getting started because it allows you to get started with distributed tracing quickly. You can easily add tracing to shell scripts as well as other applications that don't support tracing natively. And it's really simple. However, it requires a few things to set up, including a working Go environment. So it may still be a little bit confusing depending on your familiarity with Go. Telemetry Gen is another solid tool to try OpenTelemetry out. It is a utility that simulates the client to generate traces, metrics, and logs. Yes, and it does not require an application. So fairly simple. However, the data that it produces is pretty basic. It's not very realistic. We'll see. But it's still a quick way to see OpenTelemetry data, and we'll see an example of a span that's simulated by this tool in the next slide. But again, it also requires a working Go environment, so depending on how comfortable you are with Go and if you need to upgrade it or anything, that could be another piece to consider. So this is an example of a span that is generated by Telemetry Gen. Again, pretty basic, but it lets you get started quickly and allows you to see some OTel trace data. So what about when you're ready to try something a bit more complex, but you don't want to go through the trouble of instrumenting your own applications just yet? So this is a great stage to try out the OpenTelemetry community demo. Is anyone here who has tried out the demo? Oh, quite a few people. All right. So if you're familiar with the old GCP hipster shop, this is a very nicely updated version of that. And it's made up of several microservices that talk to each other over gRPC and HTTP. It comes with a load generator that simulates user traffic. And yeah, this is just to show you how they're connected. And now we're going to look at, so the telemetry that's generated from the application. It makes its way to the collector, which again, you'll learn more about in a little bit. The collector will then ingest the data, transform it in some way according to the configuration, and then finally it gets transmitted, in this case to two backends. It makes its way to Jaeger, which is an open source backend for traces, and also Prometheus, which collects and stores metrics, and you can see the metrics visualized in Grafana. So there's a few purposes to the demo. One is to provide a realistic example of a distributed system, so you can see how OpenTelemetry works and to demonstrate how it works. It provides a base for vendors, tooling authors, and anyone else really who wants to extend and demonstrate their OpenTelemetry integrations. And it also provides a living example that contributors can use to test like new versions of the API, SDK, and other components. Oh, the demo also comes with a UI that you can access in the browser. You can poke around and generate your own traffic and kind of see the trace that results to get an idea of like how things are working. So as you just learned, it comes with a couple backends. So for example, you can navigate to Jaeger straight in your UI. And in this case, you can select cut service, and you'll see a list of traces that where this service was involved in. You can click into any one of those. And here's an example of a specific trace from the list that was on the previous slide. So you can see things like name of the spans. You can look at the child spans, where it occurred, as well as the duration, for example. You can run the app locally using Docker. You can run it on Kubernetes using either a manifest YAML, a YAML manifest, or the demo app's Helm chart. And all the things that we just talked about are what make the demo great for trying it out as a next step up before you try with your own applications. Because you can use it to view various instrumentation examples in different languages. You can modify it to test and experiment with things. It provides more realistic data that you would see in a prod environment. And it also includes a few problem-solving scenarios to help you interpret your OTel data and use OTel to solve them. It also includes backends, but you can change who gets the data. So if you wanted to look at the data in a specific vendor's backend, you can do that. But of course, it can be very overwhelming. There's a lot of pieces, and because of that, you might run into issues trying to run it locally. I have before, so just something to keep in mind, but it is a really cool tool. OK, so now we've filled your first drawer with some useful tools to help you try out OpenTelemetry. What about when you're ready to take the next step?
Thanks,
Alex.
Reese. So after, thank you. All right, after seeing what Reese has shown me, I'm really excited to try OpenTelemetry, and I really wanted to try with my own application. To reduce the time it would take me to instrument code, I just decided to go with auto instrumentation, and I have two different applications I wanted to instrument. There's a Python server and a Go server. What I'm going to show you is my journey through the auto instrumentation process, because I did run into a few bumps, and I thought maybe people that have run into these bumps may benefit from it. So bear with me as I explain to you what the application is. It's not super important, but just so you have an idea. So this is the application I was instrumenting. It's a Flask application. It just has like an endpoint. I set up my requirements file, and then I set up a virtual environment. Not super exciting. But auto instrumentation in Python provides a wrapper that loads all instrumented libraries. It also provides a tool called OpenTelemetry Bootstrap that allows you to list all of the instrumentations that exist for things in your environment. And then you can install it with this nice little command at the bottom. So here I thought I would be good to go. So this is the OpenTelemetry instrument command that wraps the execution of the Python script. And I thought, this is great. This is all I need to do. I'm done, right? Unfortunately, I was not expecting to see this error message. And I thought, well, this is weird. I wonder if there's something I can do to debug this error further, because I'm completely unfamiliar with any of this. I don't know what gRPC is or proto OTLP, whatever this is. Then I remember there's an environment variable called OTel log level. This is defined in the OpenTelemetry spec, which defines all of the features across all implementations. And I thought, wow, this is going to show me what's happening in the SDK. This is great. So I ran the script with this environment variable. And unfortunately, I made no progress. Then I remember there's a compatibility matrix that shows you what is implemented in what languages. And unfortunately, as you can see down here, it is not implemented. Thankfully, it's highlighted in blue as not implemented, but it's still not implemented. It's only blue because there's a link to the issue that's open about implementing it. Anyways, so this is a really useful tool to know about, the OpenTelemetry compatibility matrix. It's a document that shows you what features are implemented in what languages. It's great until it's out of date. As with all documents, things get out of date. It's also not the easiest to parse because there's like 11 different languages, so the table is really wide, and you kind of have to like manually figure out. Anyways, it's great. Go check it out. So now that I gave up on this OTel log level thing, I decided to remember what OTLP was, and I remembered that by default, the OpenTelemetry Python instrumentation, auto instrumentation sets up an OTLP exporter for all the signals. But I'm not ready for OTLP yet. We'll talk more about what OTLP is in a second. So I decided to use the console exporter, which is just like a standard out exporter for your telemetry. So ran it again. And I thought, great, there's no more error messages. But then when I make a request, I was expecting to see at least like a span or like a metric or something. Instead, I just get this blob of like resource attributes, which is neat, but it doesn't really tell me anything about my application. And at this point, I'm like, what is going on? Maybe something is misconfigured or whatever. So I decided to do a pip freeze to see what's installed in my environment. Here, I was really surprised because somewhere along here, I was expecting to see like OpenTelemetry instrumentation Flask installed. I did a search through the Python repo. It turns out I was using Flask 3.0. There's a bug open that says it's not supported yet. And sure enough, if I scroll all the way back to my error messages, there was a really handy message that just says, it's not supported, skipping. I wish I would have seen this like at the very beginning. That would have saved me probably like an hour of time. But anyways, so I downgraded Flask, reinstalled the instrumentation package manually this time just to be sure it was installed. And here we go. I finally have a span. It was so good, right? Like you can see the span information. What you don't see is there's also metrics being captured by the auto instrumentation. But yeah, so I was super excited. This is great. So an excellent tool to be aware of, console exporter. It's kind of like printf for your telemetry. Honestly, I feel like printf will never go out of fashion. So it's super handy because if I had been using the OTLP exporter and I didn't see any data, I would have started down a path of like trying to debug, is my destination broken or is anything, like it would have just been a mess. But instead, with the console exporter, you can just see that something is emitted, and that's pretty useful. In fact, we'll come back to the console exporter later. Anyways, so I mentioned earlier, I also had a Go application. Now that I finally got data and I saw how amazing it was, I thought, OK, I'm ready to go. I'm going to get this Go version in like no time. So the Go auto instrumentation uses eBPF, which allows it to set up uprobes. If you don't know about eBPF or you're interested, I'm sure there will be many talks about eBPF at this conference coming up this week. What is it called? Cube something? Anyway, so the Go auto instrumentation supports Ubuntu, which meant because I have a Mac, I ended up running everything in Docker. Thankfully, the repo for the auto instrumentation has really handy steps to do this. This is really small font, but you can kind of see there's two services defined. The first one is just my application. The second one is the auto instrumentation that hooks into my application. And you can see here I specified the console exporter because I'm a big fan of the console exporter. Then I looked at the logs. It looks like something is instrumented. Awesome, that's great. I'm going to make a request and everything will be working right. Unfortunately, so you can see there's like a little bit of information about my request. It's not great, though, because down here I can see an error going to some port 4317, which, if you're not familiar, that's the OTLP port. It looks like my environment variable doesn't work for my console exporter. And sure enough, I searched through all of the Go auto instrumentation. And you can see here, establishing connection to OTLP receiver, which I had not asked it to, but it did anyways. So after looking through the code, OTLP exporter was the only exporter available for Go auto instrumentation at the time of this demo. There is an issue. I actually submitted a fix as part of this work to try and get the console exporter in there. So hopefully that's going to come soon, but it's not there yet. So just everybody knows, all these problems that I've run into, there's either issues or there's someone working on trying to fix it. So auto instrumentation, it's amazing. I was able to get telemetry, sort of, without any code changes. It's fairly low cost. This is a slide where I have to make the mandatory statement. Auto instrumentation will never be as good as manual instrumentation. It just can't be as detailed as you want it to be. However, auto instrumentation does intercept calls to third-party libraries that you might not instrument otherwise. OK, now we're ready to talk about OTLP because I only have one choice for my Go auto instrumentation is to have an OTLP backend. So OTLP is a protocol defined by OpenTelemetry. It's the OpenTelemetry protocol. Some people might say it's the OpenTelemetry line protocol. That is false. There is no word line in it. It's just the OpenTelemetry protocol. Nobody knows what the L stands for. So the cool thing about OTLP is that it's adopted by many vendors and many open source projects. And this is kind of a regular setup. You might have your application, you might have the cloud, and you might send your data to a hosted backend. I don't want to send my data to a hosted backend because I'm sure to mess up an API token somewhere. So I'm going to set up a local OTLP destination to do that. So this is kind of the setup. This is just me having to install the OTLP exporter in Python so that I would get over that error message that I was seeing earlier. I also got kind of tired of making manual curl requests, so I just wrote a little OTel curl, which also instruments the client-side application requests. And so all of these three applications are sending data to an OTLP destination. Now, what OTLP destination can we use? Personally, I like the OTel desktop viewer. It's a Go app that just sets up an OTLP port and allows you to view the data that comes in through a minimal user interface. It doesn't support other signals than traces. I would like it to, but anyways, I'll talk more about that later. So now, after a few seconds, we can start seeing data appear, which is exciting. I finally have like a visual representation of my data. Fortunately, you can see I'm missing my span here, which reminded me that I forgot to update my OTLP endpoint for my client application, which I did. And now you can see this super duper handy trace. It's a client talking to a server, although with the service name being unknown service for both, you don't really know what you're getting. So I updated this via another environment variable called OTel service name for each one of my applications. And now I can finally get a clear idea of what's happening in my code. This is where I want to take a pause and give a shout out to environment variables. They're great. If you haven't used them before, I highly recommend checking it out. The OTel SDK has many supported environment variables. You can see all of them in the specification itself. As you saw earlier, though, your level of support across languages may vary, so beware. Also, environment variables are really hard to remember if you've forgotten to set them. I find that it's really easy to just start an application and forget one environment variable. And anyways, OK. Then I remember I also have a Go application. And this is what my Go application looked like. You can see the curls coming from the client. You can see the responses from the server, but they're not connected. So this kind of looks like a context propagation problem. So for context to be propagated between the client and the server, there's usually some kind of propagation mechanism. Usually it's HTTP headers, not always. But it looks like something wasn't working. So I was expecting to look at the output from my request headers and just to be able to see something. This is where I want to take one moment to give a shout out to one of my favorite tools of all times, TCP dump. It's my big hammer. Sometimes I just find it's easier to look at the bytes on the wire than trying to debug application code. So sure enough, if you look at the request, so this is me doing a TCP dump on the port for my Go server. You can see there's no request header that includes any information about the trace. This is the one I remember that I broke something on my client. This is just like how you set a propagator in the Go application. So I needed to set up this trace context propagator that I forgot. And sure enough, now you can see there is this trace parent header, which is super handy. That includes like the span ID and the parent ID, trace ID, sorry. And now my trace is connected, which is super duper exciting. By the way, if the propagation was working on the client, I would have, if I would have seen that request with the header in the first place, I would have looked now on the server side because I knew at least the client is doing the right thing. Okay, so the OTel desktop viewer is great. It's my tool of choice for viewing data locally. I like that it's pretty quick to set up. It's just like a quick Go app to run. It's not the only open source tool available, as Reese showed. There's Jaeger you can use for your OTL for traces. There's Prometheus you can use for metrics. Both of those support OTLP natively. Unfortunately, this tool only supports traces, as I mentioned, and I do not recommend it beyond development. Very important. Do not deploy this in production and expect this to just work. Okay, so this is all for my local development. It's great, but now I want to send my data to somewhere that's like kind of getting me to production. This is where the OTel collector comes in handy. This is kind of the Swiss Army knife of tools in OpenTelemetry. I am going to use my collector as an OTLP destination, and then using YAML configuration, I'm going to send the data off to Jaeger and Prometheus. This is what a YAML file looks like if you haven't seen YAML before, but this is specifically the YAML for the collector. There's a couple of pipelines that I set up for metrics and for traces. And I thought, yay, I'm going to see data right away. Unfortunately, the first thing that happened was no data was going anywhere. And this is where I wasn't sure if the data was getting stuck in my pipeline because my collector output was pretty straightforward. It just says, everything is ready. Sounds pretty promising. Then I remembered that there's a debug exporter. It used to be called the logging exporter. It was very confusing. Now it's called debug exporter, which is the equivalent of the console exporter I mentioned earlier for the SDK, to be able to see if any data is coming into my pipeline. So I just added it as an exporter to both pipelines. And sure enough, when I restarted my collector, I saw that no data was coming in. This pointed me to the problem of the fact that I hadn't changed my OTLP destination from the OTel desktop viewer to the collector. When I did that, data showed up in the output. And of course, now data shows up in my backends. Yay, it's exciting. So the collector is great for doing all sorts of things. We're not going to be touching the processing capabilities of the collector in this talk, but it's great for doing all sorts of transformation on your data. The best thing about the collector is that you can set it up, and then you can have all your applications send your data to it. And then any kind of processing or any kind of sending it to a different destination, you can just modify YAML and it'll happen for you, which is great. There's also something like 240 components for the collector. So there's a lot of stuff in there. So the community manages two distributions of the collector. There's the core, which has this lovely set of components, which is a very small subset of components. Then there's contrib. I couldn't make the font small enough to fit all the components on here. This is cut off at receivers. There's a whole list of other components that's missing here. So what if you don't want the minimal component because you really care about this fcloud exporter that's right over here, and you don't want this because this is a lot. What do? Well, thankfully, there's the OTel collector builder, which allows you to specify a manifest file. Then you run this beautiful Go command to install the builder and run the builder. And then you can get a list of all the files that are generated by the builder, but also the binary that you really want. So the builder is great. If you want your own version of the collector that's just right for you, highly recommended. Unfortunately, oh, by the way, this will make SecOps really happy because you've limited the number of components that they have to worry about. It can also dramatically reduce the size of the binary that's produced. Downside is it's one more thing to manage, which kind of sucks. But anyways, now that you have your collector and you're totally ready with all your instrumented code, I'm going to pass it back to Reese, who's going to get us to production.
Thank you, Alex. All right. So you just learned about the collector, which is a super cool tool. And when you are ready to deploy into production, you have several options for where and how to install the collector. So you can use Docker, which is also great for running it locally. You can install it as a standalone binary on bare metal on Windows, Linux, and Mac OS. If Nomad is your orchestrator of choice, you can deploy it there. And of course, Kubernetes, which we are guessing that's probably most of you out there. So we'll touch a little bit on the two options you can use, Helm chart and operator. I do know that we are running up on time, so we'll just take a quick little look here. So the collector Helm chart is one of the ways you can install the collector on Kubernetes. It facilitates the installation and management of a collector deployment in Kubernetes. The chart supports 3 deployment modes, and it requires you to set one depending on what your use case calls for. So daemon set, deployment, or stateful set. And because a lot of the components that you would want to use for the collector require special setup and permissions to access the Kubernetes API server, it comes with a few some handy presets to help you configure those a little bit easier. However, Helm charts can be complex, and the presets are recommended as a starting point. If you need to add extra or more advanced configuration, it's recommended that you do that manually. This is the default config file for the collector that comes with the Helm chart, and you can see the default components that it provides, and you can update these settings by changing the values.yaml file. There is also the operator, which is an implementation of the Kubernetes operator. And it has 2 primary functions, which is to manage the collector, as well as to inject auto-instrumentation of workloads using OTel instrumentation libraries. So you don't ever have to touch code, as you learned about that with Alex earlier. The operator creates a config map that contains a collector config. So anytime you modify the collector config, it will actually automatically restart all related collector instances for you. It also supports the use of an optional tool, but potentially useful thing called the target allocator, which manages Prometheus metrics without the need to install Prometheus. And it supports all 4 deployment modes, so whatever the Helm chart supports plus sidecar. However, as you also just found out, auto-instrumentation is not available in all languages at this time, so you want to double check with the language or languages that you're using. And operator expects Start Manager to be installed on the cluster, so that's another thing to consider. And finally, there are some components that are not recommended to be used depending on the deployment mode that you're using, so I would recommend looking at the documentation for that. And I believe we have time to cover a couple of bonus tools that made it in last minute. And also there's like other tools, of course, load balancing expert that we didn't cover, but OTelBid is a cool one that came to our attention in the last week. We just have a screenshot of it, but it's a way to check your configuration and validate your collector config, which is something I've heard that end users really want, so you might find this really handy. It is still in the early days, and we didn't have enough time to get our local dev environment set up, but it looks really cool. And also, the builder GitHub action, which since Alex helped build, I'm going to have him.
I can
chat about it. Oh,
yeah.
I keep forgetting.
You can.
There.
There we go. Yeah. So I got tired of having to create a repo that contained all of the same actions. So run the builder, install the builder, and have a bunch of files. So I thought, why not just have a GitHub action that can do all of this for us? So I wrote this GitHub action. It's still very alpha, if even alpha. But you can just check in a manifest file, create a workflow in GitHub that looks kind of like this. And it will automatically generate a binary of the collector for you, which is super handy if you happen to have many repositories like myself that just have a tiny bit of code to generate collectors. Yeah, so try it out. I'm looking forward to adding Docker support to it. But anyways. And I think that's it. I think that's all we have.
Thank you. Question?
I just want to plug the observability party that New Relic is hosting with Honeycomb, and Observe IQ is happening tomorrow. It's going to say sold out online. It's not. So we would love to see you tomorrow night. And I think we're ready for questions, I guess.
Could you talk a little bit about the relative merits of auto instrumentation versus doing it by hand the hard way. I've heard stories of auto instrumentation gone horribly wrong at great expense. And just wondering what the balance is of learning curve between wanting to see something in a toy test environment versus having control over exactly what you're looking for in a production environment.
Yeah, so I think depending on which implementation you're using, there's different configuration you can use to do various filtering for what data is actually emitted by auto instrumentation. So I would probably start with just trying out to have a look at it like in your dev environment to get a sense for what's happening. And then tweak it maybe before putting it into production, if you can. If you can't, then I would definitely want to send all the data that's generated to a place where it's not going to cost me money first. So maybe have like a collector that's running, and then you can see the data locally before sending it to like a third-party vendor, for example. I've definitely found it super useful when I'm starting with a new language, especially. Some implementations are quite advanced, like the Java auto instrumentation is really good. So yeah, I think your mileage may vary, but when you're just getting started, it's great.
Thank you. More questions? Yeah.
First a comment, then a question. The comment is you just demonstrated how complicated it is to use OpenTelemetry even as of today. Like, it's not a new project, but it still felt very complicated to use at first or to implement in the code. The question then is how would you move or translate traces from auto-trace to implementing into your code? Like, you start with auto-trace, you have something, and then you say, okay, now I think it's time to implement in my code because I want more. But what would you do to keep the original traces from auto-trace to kind of still be the same and not be lost into your old traces versus your the new traces you're going to generate?
Yeah, so what you would do is you would use the API from the OpenTelemetry API and just instrument your own code. And auto instrumentation should work with your own manually instrumented code, like basically seamlessly. When you're adding like a span to a function call in your code, if you're using auto instrumentation to do the kind of the running of the code, it should just add that span inside whatever context is current inside your application. So it should work seamlessly.
You keep the auto trace,
yeah,
and you add your own at the same time.
Yeah. So I think auto instrumentation can get you maybe like 60% of the way to like an instrumented application. So then the last 40% is just you manually instrumenting the code that you care about. But then you combine that with the stuff that's generated through auto instrumentation. And as mentioned earlier, if auto instrumentation is generating way too much noise for you, you want to have some kind of filtering, either at the application level or at the collector level to just filter that out. Yeah.
Okay, we ran out of time for more questions. We will be back at 11:25. We have a slightly bigger break this time. Okay, thank you. our sessions, and now we have a challenge for Adrian. He will try to explain us is it really possible to have zero vulnerability container running. So over to you, and we'll be hitting.
Thank you very much. Yeah, my name's Adrian. I'm from a company called ChainGuard, and we basically do software supply chain security. And today, I will talk about how you can run with zero vulnerabilities. First, I'm going to have a quiz. And you all look scared now, so don't worry. This won't take long. Most of you, I think, are probably aware that vulnerabilities are given like a CVE number. So I'm going to give you some CVE numbers, and I want you to tell me what the vulnerability was. So I'm going to say like CVE 2014-0160, and you're all going to shout Heartbleed, right? Yeah, you got it. Yeah, so please shout out if you know any of the answers. I will give you a few clues and stuff, don't worry. So the first one we have is CVE 2017-5638. Does anybody know which application framework this was a vulnerability in? And for bonus points, and this is a bit of a clue, what famous data breach was it involved in? Do you know it?
Is that struts?
Yeah, well done. Whoa, I didn't expect anybody to get that. Apache, so yeah, it's a remote code execution in Apache struts. If you don't know, Apache struts is a Java MVC framework, and basically it allowed remote code execution via HTTP headers. So that made it kind of really easy for hackers to scan the internet for vulnerable systems and exploit them. Now, the main reason that I mention this is because it was part of the Equifax data breach. And the Equifax data breach was like released private financial data of almost 150 million US citizens and 15 million UK citizens. And I think there was a few Canadians as well, but less for some reason. It was one of the largest data breaches in history. The CVE itself was a 0-day, but the Equifax hack didn't start until 5 days after there was a patch released. So theoretically, at least, Equifax could have patched their systems and avoided this exploit. Okay, CVE 2022-0847. This is a CVE that's big enough to get its own name. So can anybody tell me the name or what it was a vulnerability in? So it's a vulnerability in a very key piece of software. Any ideas? Sorry? No. It's 2022.
Kernel?
Yeah. It was a kernel vulnerability. Do you know the name of it? Sorry? No, the name of this was given, like the vulnerability itself was given a name. It's okay. It was Dirty Pipe. Yeah, so this was very similar to, I think it was called Dirty Pipe, because can you remember the Dirty Cow vulnerability? I think that was years and years ago. So I think it was kind of named after that, because it had a similar sort of impact. You could write to read-only files. Now, on the face of it, that doesn't actually sound that bad, but in reality, it is bad because you can create like, you can basically give yourself super user privileges and read things you shouldn't read, etc. So it's typically used as a privilege escalation exploit. And also, apparently, it affected lots of Android phones. Okay, this is the big one that you are going to get. Does anybody know CVE 2021-44-22-8? This gave a lot of organizations a very bad out. Yeah, it's Log4j. Or Log4Shell, I guess is the name of the exploit, but it was in Log4j. This has been described as the single biggest, most critical vulnerability ever, which is a pretty bold claim. But Log4j software was, and is, I guess, so prevalent that all large organizations were running it somewhere. And it meant that millions of ops and security staff across thousands of organizations had a very bad week or weeks trying to identify and mitigate all applications that were running Log4j somewhere. And millions of devices were affected. There's a lot of IoT software, such as TVs and so on, turned out to be running Log4j. And my point with all this is that vulnerabilities are pretty bad, right? They get you hacked. They cost organizations millions and reputational loss, also lawsuits, ransomware, and it goes on. vulnerabilities can end up being a very bad day. So in this talk, we're going to be talking about vulnerabilities and how they relate to containers and container images. Now, most of you, you're at this conference, so assuming everybody knows what containers are, but have most of you used vulnerability scanners? You know, like Privy and Gripe and Sneak and so on? I know you know Sneak. Cool, I think it's most people. So vulnerability scanners take images, make a list of all the software inside them and the versions, so kind of like an SBOM, and then compare that to various security databases and return a list of any known vulnerabilities. And on the face of it, this sounds great, because I can scan my software, find the vulnerabilities, fix them, and push to production vulnerability-free. Or at least that's a theory. But, yeah, it sounds like most of you have played with a vulnerability scanner, so you will know this is not the way things go. There's a bit of a problem. And the problem is, lots of images have vulnerabilities. Like this is running Docker Scout. So Docker Scout's quite a nice scanner. And the reason I use it is it gives quite nice output that I can use in slides and stuff. But if I run Docker Scout on the Nginx image, I get 40 vulnerabilities across 23 packages. And it's not really anything you can do about it. Like that's the official image. It's up to date, and that's what you get. The Node one's worse. In Docker Scout, I think it finds 90 vulnerabilities across 33 packages. You run it with Gripe, you get a lot more. I'm not quite sure of the difference. I'm slightly thinking Docker Scout might be more accurate. I'm not sure. But the point is that you end up with like a whole list of CVEs in the image. So, by the way, both those scans I did yesterday, so it should be exactly the same results today. But you know, you get just this huge list of CVEs that you know it's hard to do anything with, and hard to figure out even if they affect you at all. Because the majority of them aren't going to be exploitable. But which ones are? I don't know. And I think a lot of people get to this stage and kind of give up, or at least end up with suboptimal results. So you know, I've heard of like security teams trying to investigate all the vulnerabilities and sending images back to developers with instructions to get rid of the vulnerabilities or certify that they can't be exploited. And platform teams providing base images that already have so many vulnerabilities that nobody notices the extra ones in the application. And then other people spend so long investigating vulnerabilities that there's a dozen more by the time they've finished. But there are solutions. There are ways that you can make your life better here. So I'm going to look at some variants of the Nginx image. So the first one's the official, this is what you get if you do docker pull Nginx latest, and that's actually based on Debian. And if I use quick view, it's quite nice because it also shows me like which layer the vulnerabilities come from. But note, there's 232 packages here, which is quite a lot. Apparently there's one critical vulnerability, 3 medium, and 36 low. And I can see this critical actually comes from the underlying base image. But there's apparently 3 medium vulnerabilities coming in from Nginx itself. We can do, so that's 40 vulnerabilities in total. We can look at the Alpine version, and that's a lot better. So we can see there's actually 0 from the underlying base image, but apparently there's 3 in the Nginx layer. Also note, a lot less packages. So a lot less software in that container. And then I've got the ChainGuard image, which you can pull at cgr.dev chainguard/Nginx, and there's 0 vulnerabilities. Again, I ran this yesterday, but I suspect you'll get exactly the same results today. And also note, there's much less packages in that container. I haven't looked. We can go and look. I'll kind of get into what we do in a minute. No, you're good. So, you know, how did we get to 0 vulnerabilities? Exactly to your point. And actually, it's kind of weirdly simple. There's 3 things we did. We were really aggressive about cutting down the amount of software in an image. So in our images, we tried just to have packages that are required to run the application itself. We don't have like unneeded operating system components. We're really aggressive about keeping things up to date. So we're always pulling like new releases and so on. And on top of that, we do apply patches in some cases and also issue security advisories. So on the dependencies point, just coming back to the stats, Debian, the Debian Nginx image had 232 packages. So that's sort of Debian components installed in it. And the majority of those aren't needed to run Nginx. Alpine does much better. It has 79. I think also one of the reasons it actually has more than Wolfie is because of the way they've separated out the plugins for Nginx. So that's Alpine probably in reality is a similar number of packages to Wolfie. But one of the key points is if you're using Nginx or Debian, what happens if there's a new release of software? The upstream project will release a new version, and that has to be then picked up by Debian or Alpine, who have to create a new APK or deb and release that. And then Docker or whoever makes the image has to create an image with a new version of that package in it. And typically what you'll find is that process takes 1 to 2 weeks. Okay, so from like there being a new release upstream to that getting its software into a Docker image is 1 to 2 weeks on average. And that's one of the reasons that we created Wolfie. So Wolfie is our own, ChainGuard's own Linux distribution. It's called Wolfie because ChainGuard's mascot is an octopus called Inky. And Wolfie is the world's smallest octopus. We couldn't call it Inky because I think some other like security software is called Inky, unfortunately. And we sometimes call Wolfie an undistro. That's just because Wolfie is like a full package repository with everything built from source, but we don't package a kernel. Like at the minute, Wolfie is just designed for creating container images, and of course, containers runtimes come with a kernel from the host. Wolfie's APK and glibc based, so APK is the Alpine package format. However, we're not Alpine compatible. We've compiled everything from source against glibc, so you can't mix and match Alpine and Debian packages. Wolfie is purely rolling based, so there's no point in time releases. There's no like Red Hat 9 equivalent. It's just a rolling release for Wolfie. All our packages come with SBOMs, and we target both ARM and x86-64 architectures at the minute, possibly more in the future. We did have to come up with some of our own build tooling, which is open source. You can try it out yourself. There's 2 key components. Melange, which is what we use to build APKs. It's basically a bit more pipeline-oriented than the Alpine tooling. And APKO or APCO, I kind of rotate between saying the two myself, so I'm not sure there is an official pronunciation. But what APCO does, it's an equivalent of Docker build, but it's much, much simpler. Like, we don't do Docker run statements. All we do is say, hey, take this bunch of APKs and create an image from them. And that's it. You can't add in arbitrary files or anything. It has to come from an APK. So it's much more constrained than Docker build. And for that reason, it was much easier to make it reproducible. So you run an APK with build twice, you get exactly the same object out. And what that means is, because we control like the Wolfie distribution and the building of images, if an upstream project has a new release, we can pick up that update, we can create a package for Wolfie from it, and we can release a new Docker image or container image, OCI image, for it, all like sometimes within the same hour, at least within the same day. So we've gone from 1 to 2 weeks to get an upstream fix or new release to under a day, which is a big gain for us. The other thing we do sometimes is apply patches. So generally, you don't need to do this because the upstream will take care of it. But you might find upstream won't do a new release, particularly if a vulnerability is actually in a transitive dependency. So for example, the vulnerability is not in code the project themselves has written. It's in like a module or a library that they pull in. And so they might not do a release just to fix that. And what we do in that case is we'll pull in the project and we'll have a patch to update the dependency. But of course, we're still running the same version of code as upstream. So if they're 2.02 Our code's still 2.02, but the vulnerability is fixed in our version. So we need a way to tell the vulnerability scanners, okay, we are running version 2.02, but in Wolfie, we've addressed this vulnerability. And the way you do that is through something called a security advisory. So to explain this, I'm going to take this report. This is running gripe on a Alpine Redis image like months ago. So I can't remember how many months ago. But this was the results from the gripe scan. At the same time, if I ran the gripe scan on the chain guard image, you got 0 vulnerabilities. I'm going to explain why that is, with particular relevance to this critical vulnerability 0543. So back to security advisories. So security advisories are just YAML files. You can go and check out our advisories at github.com/wolfie-dev/advisories. But they basically look something like this. So we've got a package name. So this is the Redis advisory. It looks similar today. There might be a few more advisories and so on. But you'll see here, CVE 2022-0543, and we've marked it as fixed, and a version, and a timestamp. So when the scanner scanned our version of the image, it could see this and say, hey, okay, it's not vulnerable to this. But if I go and look here, because the question is, well, why didn't Alpine do that? But the thing is, the Redis image does not use Alpine to install Redis. It installed it via a Docker file that went and grabbed Redis from the Redis server, downloaded it, and compiled it. So there was no, the scanner can't go to Alpine because it's not an APK package. So there was no way for the scanner to know that this vulnerability did not affect that version of Redis. And it didn't, because I think this vulnerability was something to do with Debian packaging. There's no way that image was actually vulnerable. It was a false positive. But there was just no way for Docker to say, hey, this doesn't affect us. Now, in the future, that might change with stuff like Vex. But yeah, at the minute, that's how things work. And why sometimes we have 0 vulnerabilities when other things do show vulnerabilities. Yeah, so that's how we get to 0 vulnerabilities. But the question is, okay, that's how ChainGuard does it. But what about me? Like, what about the average organization? How can they get their images to 0 vulnerabilities? The trite answer is, of course, use ChainGuard images. And we do have images for lots of stuff, like Nginx, Redis, Vault, Prometheus. And we also have base images, so please do go and check them out. But to give a better answer, there's several things. Like cutting down dependencies, one of the easy things you can do is use smaller base images. A very simple gain can be to change to like Alpine or Debian Slim if you want to keep a glibc based. And that will really cut down the number of packages in your images. You can go truly minimal and use Scratch, which I'll talk about in a second. And then there's stuff like the Google Distroless base images and, of course, ChainGuard base images. Now, Scratch is the completely empty image. And that can be useful in some cases. Because if I have something like a Go program or a Rust program that I can statically compile, I can put that into the Scratch image and run it. And in some cases, that'll work fine. In the majority of cases, though, what you'll find is most stuff requires a few more operating system things. CA certificates is the common one. So if you want to talk to anything over TLS, you're going to need CA certificates. Directory layouts, a lot of applications will require or expect like /home, /etc, /temp. And users. Some applications expect a user to be defined. But what you can do is, create an image that just has that and nothing more. And that's exactly what the Google Container Tools Distroless project did. So they took Debian, stripped it right down, so all it had was the bare minimum you needed to run most applications. It's smaller than Debian and Alpine. I think it's about 2 or 3 megabytes. It doesn't include a package manager or shell by default. But there's a limited number of images. There's like a base image for working with static binaries. There's also like a Java version, and I think there's a Python version. But there's not much more than that. The other thing is it's quite hard to extend. Because what you would like to do is say, okay, this is based on Debian. I just want to stick another dev file in there that my application needs. But that's actually quite tricky, and you'll find yourself playing with Bazel or Bazel, and yeah, that's not my idea of fun, although other people do like it. And then you have ChainGuard-based images. So ChainGuard was founded by, or amongst others, Matt Moore and Dan Lawrence. And they were actually the people that also started Google Container Tools distro list. So there's a direct lineage to the ChainGuard-based images. And the major difference, really, is that our images are a bit easier to extend and customize. So you can use our tools like APKO, but you can also just use straight Docker files and so on. Yeah, our images also come with SBOMs and are continuously updated and based on glibc. The other thing you should look at doing is trying to cut down your dependencies. So if you're not doing it already, look at using multi-stage builds. So you've got like, so you don't end up with all your build tooling in your production image. So for example, if you've got a Java application, you'll use a JDK image to compile it, but then copy the jar over to a JRE image, which will be much lighter. And similarly, like try not to have dev or debug dependencies in your final production image. Also, if you can, just pull in less libraries. Like, if you're pulling in a library to make one function call, think about if you can, not to do that, because every time you pull in a library, you've got to try and keep that library up to date, or it might end up getting you compromised, right? I do know that's a lot easier to say than it is to do. Other thing is keep updated, and this is probably the critical one, and I think where most people fall down. A simple way to do that is to use some tooling like Dependabot that will keep telling you if there's new versions of stuff available. Google also have this concept of build horizon, which I quite like. And the idea is that all software needs to be continually rebuilt and redeployed. So even if my application hasn't changed in the last 6 months, I shouldn't be running the container for 6 months, right? I should be like taking it down and replacing it with a new version, because although the application code hasn't changed, the dependencies and other stuff in the image will have. So at Google, they apparently, every image is updated or refreshed every week, I believe. Okay, so in summary, please try and use better images and better base images, and check out ChainGuard. Be aggressive about reducing dependencies. Don't run more software than you need to. Keep your software updated. Again, I really think that's the key point that people need to get to, because sometimes you don't want to update, right? Because we're scared to update because sometimes things break. But the tension is, if you don't update, you end up getting compromised. So do try and be aggressive about keeping stuff up to date. And if you do all that, you can get to 0 vulnerabilities. Okay, thank you very much.
Any question from? Oh, a lot of questions today.
So I'm curious when it comes to the patching. So you all have engineers there who are patching all these random packages. How do you all manage that? It seems really hard to go into a random piece of software and update it.
Right. So we generally won't write our own patches. We might update a library or something, but we do have patch files. But what you'll generally find is that patch will be taken from like a GitHub PR or something. So it's pretty rare that we have to write our own patches. Like, we're not experts in all the software everywhere. So I think it's your point. Yeah.
Yeah, I had similar question, but is it sustainable? It's too much catch up to play with so many softwares out there. How do you decide what to keep patched up and what to ignore, and
So we run we use Gripe internally. So that we have basically that running on our images or in our packages continuously. And so that kind of tells us what we need to look at all the time. I hope it's sustainable, because it keeps me in a job.
I agree. And just one more thing. The database that you showed about when it was patched and who maintains that, how it's curated, where is the data?
The advisory stuff?
Yeah, advisory.
Yeah, so we have a tool, wolfyctl, and we just type wolfyctl and then the package, and it fills out the information automatically. So that date is just when we updated it, basically. So we were never, the vulnerability I showed, we were never vulnerable to. But that date is just when we said we weren't vulnerable to it.
So the universe of software that someone might want to run is enormous. NixOS has something on the order of about 50,000 packages that they derive things from. How big is the Wolfie universe of containers that you can reasonably expect to have zero known defects of? And like in practice, how much does that constrain development because you're working in not the complete universe of software, but a smaller known universe?
So we can look at, oh, maybe I can't. I was going to try and bring up the terminal. Can I come out of here? Where's my terminal not showing? Oh, I can show you in a minute how many packages there are in Wolfie, but it's already fairly big. It's certainly not the size of Debian and nowhere near like NixOS, which NixOS is like enormous. But NixOS, it's also not very updated. Is the problem. You quite often find things are broken or out of date. Of course, we'll try. The packages we add are generally in direct response to customer requests. We are also, Wolfie is very much an open source and community-based distribution. So for instance, we're moving to OpenTofu, for example. We may keep a separate repo for differently licensed stuff that our customers request. But yeah, does that answer the question?
I think that is. I think that answers the question, yeah, thanks.
We have a lot of,
So you mentioned that chain guard images will sometimes patch upstream code in the image itself. I'm wondering, so like the protobuf package dependencies are notorious for introducing incompatibilities in patch versions. And I'm just thinking, in terms of package reproducibility, if chain guard is changing to a more recent upstream patch on an underlying transitive dependency, that could introduce incompatibilities that your unit tests in your development stage didn't catch, because your image is actually patched it out of band from your reproducible build in CI/CD. Have you seen in the community these problems manifest themselves in any way, and is that something that you guys are concerned about?
I've not seen that. I think what you're saying is basically when we patch things, well, we've changed something and that could break people, right?
Because your build might be reproducible, right? But the unit tests are operating on a different version of the actual
right.
of the actual patch.
We're not running the upstream tests.
Yeah.
Well, we might in some cases. For example, I think we run the Java ones. But yeah, you're absolutely right. And what I would say to you is, we tell our customers to run a digest when they pull an image, so they always get exactly the same version of the image. And then if something breaks, when you do an update, you can roll back to exactly the old version that worked before. But again, it comes down to that point about being aggressive about updating versus reliability when sticking on things. It's yeah.
Why didn't Dan and those folks build Wolfie in Google then?
Ask Dan, I guess they probably wanted to. I would say, however, I do have a big shout out for Ariadne. So Ariadne Connell is the person that's behind Wolfie. And she had all the experience from working on Alpine. And that's why we use APK really. And without Ariadne, this wouldn't exist. Yeah. So maybe the answer is he didn't have Ariadne.
Yeah.
We have 3 questions for you now. Okay.
I have a feeling also that maybe Google wants the scanners to work as scanners, whereas if you have 0 CD images, who's going to buy scanners?
Well, yeah, but that would be.
Somebody has to pay money.
So I would argue that using Wolfie doesn't get rid of the need for scanners. So.
No.
Hey, Adrian, great talk. So one question is there are multiple packages and multiple CV fixes keeps on coming. So how do you know there are sometimes there are no fixes available from the upstream. So how are you handling that?
I'm not sure entirely. Like, most of the time, we just want to be pulling the upstream latest release.
Okay.
And the only time we'll patch it is if like there's a vulnerability and the upstream isn't doing a release. But then the upstream will do a release and we won't be doing the patch anymore. Does that answer the question though?
Yeah, like it doesn't exactly solve the zero vulnerability in the images, right? For example, I have.
Oh yeah.
Yeah.
There will be at the minute like Wolfie packages with vulnerabilities.
Okay.
I'm not sure which ones. So you do have to dig a bit to find them.
Like Nginx, I think is a popular application, but probably it would make sense that the Nginx project itself releases these artifacts now. I mean,
what do you mean?
As in, like,
what's an artifact?
before like the container images, for example. Why is there a wait between it coming to a package and then that package is then used for building images?
But then there's a question about what base should Nginx use for their images?
Whatever is the basic minimal, no? Like, isn't that how it should be?
So we compile Nginx from source, and we do it for like a couple of architectures, and we do it on top of our base system. But other people will want a Red Hat base image, and other organizations want an Alpine base image, and that needs to be compiled against Muzzle. So there's all these different requirements, basically. And some people don't want an image at all; they just want to run Nginx. So I mean, some projects definitely do Docker releases. I'm not really sure why Nginx doesn't, but in general, I guess it's just a separation of concerns.
Okay, thank you.
So, last question.
Quick question, you might know, maybe not, about the image composition and the use of hard links and soft links. For example, bin shell is a soft link, at least with the image I'm dealing with, is a soft link to an absolute path. Bin busybox, where, for example, busybox, they use hard links. So do you know much about the use of hard links versus soft links in your images?
Not really. I'm sure this was did you open a PR or issue on this? Or talk to Ariadne or something? I'm sure I saw this in Slack at one point.
It's not quite an issue. It's related to an image that you guys created for Slim Toolkit. You created Slim Toolkit debug image.
I did see this.
And I tried to kind of test it and all of that, and I came across a few gotchas. And
I don't know the exact reason, to be honest. I'll look it up later, though.
Sure.
Okay. Thank you so much. And yeah, we'll be back in 4 minutes. Okay.
Thank you.
So get away, please.
Cool. And I'm going to pull the slides back up because apparently they moved. Where did they move to? That's weird. You would think I would know how to do this by now.
Just stop. Oh, no, wait, there you go. Go back to town.
Are they like on a different?
Yeah, they're on a different desktop.
Why?
Because Google is why we can't have nice things.
Cool.
All right, there we go.
I hope that was recorded. Cool. Thank you for coming to our presentation about taking security to the edge of the factory floor. I am Andrew Gracie. I am the product manager of industrial IoT and manufacturing at SUSE.
And I'm Flynn. I'm a tech evangelist for Buoyant, working with Linkerd. Hi.
Yeah, so we're going to talk through a couple different things. I'm going to give a quick overview of kind of cloud native and edge and how those two things work together. Flynn's going to talk about why specifically we're using Linkerd, and then the Linkerd architecture. Then we're going to talk a little bit about extending the service mesh.
Going and assume this is going to fix
we're going to roll
itself.
with it, and maybe I'm just going to unplug this and plug it back in and see what happens. Turn it off, turn it back on. So I found it. Come on. Okay.
There we go.
And then up, and then back to that. Cool. Awesome. Now I know how to do that. Yeah, so Edge is really all about the devices that we want to connect to. And we want to enable the flow of events and data between these devices so that we can actually build a useful control loop. This control loop is actually the compute that we want to move closer to the devices that are being controlled. And that's really kind of the main crux of Edge, is moving all the compute closer to and shortening that control loop so that you actually get less latency and just generally a safer, more secure, easier to manage environments, hopefully easy to manage. So most of our IoT devices are connected to a gateway, at least historically. This is a part of the OT kind of world, and a lot of the specs that they actually, the best practices that they have. And then those gateways are all then connected to the servers that are running the actual control loop logic, as well as things like Historian, Digital Twin. If you want to get really fancy, Metaverse, there's all sorts of compute that goes on right there. Yeah. So let's use Kubernetes with it, right?
Even if we don't want to, a bunch of other people already are. So we may as well roll with it.
Exactly. It's got the right tooling around it. People really like GitOps for configuration management, deployment management, kind of all of that. And this is really where the cloud native piece comes in, right? I'm going to be really reductionist here and say that cloud native is really I just realized. Okay. Before the demo went to sleep and caused issues later, it's really about being able to be declarative with your configuration and then have a reconciliation loop that always self-heals into the desired state. So, and lastly, it's popular. So it's what we can hire for. It's what skill sets are actually out there. And that's honestly a really big piece of calculus for it. So now we need to think about like how the communication is actually happening. So the gateway to device communication is going to be done through things like serial protocols, USB protocols, really any number of protocols: OPC UA, Modbus, Profinet, LoRaWAN, Bluetooth Low Energy, as well as almost every single vendor of devices has their own proprietary protocol, and it's really annoying.
You forgot IEEE 488.
Thank you. Can't forget that one. And these do tend to be reasonably secure. You might argue LoRaWAN, you might argue Bluetooth Low Energy on it. Yeah, we'll see.
There are things that can be done to make them secure, and people tend to think a little bit about that. So it's better than ClearText TLS over Wi-Fi.
For sure.
Which we tend to have a lot of too.
Yes. So then the gateway to cluster network is potentially less secure, let's say. It could be just some unsecure network. It could be going out to the cloud. It could be over Wi-Fi, right? It could be satellites.
It could be flaky. It could be massively unreliable. It could be slow. We would like to change all of those things.
Right, all sorts of issues. So we know how to solve this problem, right? Let's add a service mesh. Specifically, one more build. Linkerd. And for the a little bit better explanation of why Linkerd, I'm going to turn it over.
As we do the dance of trying not to break any cables while we swap spaces. Yeah, Linkerd is a good choice for stuff like this. It's low overhead. You can run it on relatively low-powered devices because it doesn't consume a lot of resource. It's built to be easy to configure and secure from the ground up. This is why it's all written in Rust instead of other things like that. And a particularly nice thing for this particular application is that Linkerd is also completely independent of your network topology. So it doesn't actually care whether you have these things in multiple clusters in the same cluster, whether there's the public internet between them, whether it's a satellite, whether it's a VPC. It's built to cope with all of that. In terms of architecture, Linkerd is a service mesh. A service mesh is an infrastructure layer that provides security and reliability and observability at a platform platform level underneath your entire application so that you don't actually have to change anything about your application. The way that we do this in Linkerd, like in many service meshes, is by sticking user space proxies next to all of your application pods and then redirecting the network so that all of the communication goes through the proxies so that the proxies get to mediate everything. They can enforce MTLS, they can do retries, they can do circuit breaking, whatever, again, without having to change the application. But they also get to measure it, and so they can immediately start reporting statistics on how many of these things are working, what is failing, and they can do this uniformly across the entire application. We also tend not to talk about it very much, but there is a control plane. The data plane, which again, ultra lightweight proxy is written in Rust so they are safe. The data plane is wrangling your data, and then the control plane is wrangling all the proxies. So, things that are special about Linkerd. One of the big ones is if you take Linkerd and you mesh your application into it and you do absolutely nothing else, you will have security out of the box. I'm not going to lie, you do have to do some extra configuration to get retries or circuit breaking or whatever, all the reliability things, because we do not have the capability to know right out of the box what can be retried, for example. But that's pretty easy, right? Ultralight, in this case, you're talking about megabytes of RAM as opposed to gigabytes of RAM. Latency is often harder to measure, but there are most situations we can be bringing in latencies down in under a millisecond for the proxy itself. It's very simple to operate. We have made a point of focusing on operational simplicity with Linkerd. You do not need an army of SREs to run it. And I've already mentioned security out of the box. So one of the questions we get every so often is, oh, well, how do I disable MTLS in Linkerd? And the short answer is you kind of can't. I think there's a way to, well, I mean, there's a way we can do things like, oh, no, you need to skip this particular port that's coming in from the ingress. But that's about it. Other than that, you're going to get MTLS whether you want it or not. And you will get identity checking whether you want it or not, because that's part of MTLS. Let's see. I already mentioned that the microproxy is in Rust. It is not Envoy, despite the fact that everybody loves to build service meshes out of Envoy. Let me be clear. I am the original author of Emissary Ingress. Emissary is based on Envoy. There's a whole lot of stuff I really like about Envoy. but not if you're talking about running thousands of them in a cluster. Don't do that. Use something smaller and lighter that's built for the task and could be better at it. That is the Rust proxies. I can also point out here that actually two things. One is we get a lot of really cool asynchronous stuff and state-of-the-art networking, in large part because a lot of the Linkerd maintainers have been contributing that to the rest of the Rust ecosystem. And the other thing I should point out here is that philosophy that the proxy really should be an implementation detail. If you're using an Envoy-based proxy, you will typically need to hire people who are experts with Envoy. As far as I know, the only experts in the Linkerd proxy are the Linkerd maintainers, which we really like, because you should be able to use a service mesh without being an expert in the proxy that's slinging the data around. That should not be necessary. So, actually, I think let's hand it back over to you to talk about some of the challenges here, and I'll heckle, or something like that.
Yeah. So some of the challenges that we run into, kind of taking a step back to this architecture, is the question of like, should these be Kubernetes, right? Should all the gateways actually be running Kubernetes, right? Easy question.
Okay, not always.
Cool, we're done, let's go to lunch. But why not, right? There's a few reasons, right? The first is not everything is greenfield, right? We've got a lot of devices that are already out in the field, right, that we have to integrate with. Some applications are just not appropriate for Kubernetes, right?
For example, we've got that robot there, or the Bunsen burner, and those might actually have hard real-time requirements.
Yeah.
Right. You probably don't want Kubernetes to be getting in the way of things with hard real-time.
You're going to be real scared about what a lot of cars are doing.
That's true. I'm going to go hide in the corner now and weep for life decisions or something.
We also, as you might have noticed, we're actually running on battery power up here, right? So we're really concerned about power consumption. We're also concerned about simplification, right? Every component that you add is a chance for something to break within reason. And there's, lastly, there's an economic choice, right? Why make our users spend more money on their devices if they don't need to? Especially when we're talking about IoT devices, where we're talking about millions of these things, right? An extra couple of dollars turns into some very real savings. Especially, yeah, maybe tens or hundreds of dollars would be the difference. So just a quick story, we're good on time. Quick story, a lot of these ideas actually came out of, I had a week, I don't know, maybe 6 months ago, where I probably had 10 different customers within that 1 week ask me, how do I get K3S to run on this hardware with 1 gig of RAM along with my workload and everything else, right?
And the answer is you don't.
Right? So I mean, I work at SUSE. I really like K3S, don't get me wrong. But it's not the silver bullet, right? And so it kind of made me think, and I finally actually got to, there was a customer that it was actually appropriate to have the conversation with, where I was like, okay, cool. Why? Why are you asking for this, right? And the answer was plain and simple, because everything else in our environment is GitOps. And so we want to be able to make everything GitOps, so completely top to bottom. I'm like, cool, that makes a lot of sense. Let's do that. But that doesn't necessarily mean Kubernetes, right? It just means overarching should be cloud native. So how do we balance all of these needs while giving a comparable operator and developer experience, and hopefully a better developer experience? So that's where we started looking at actually extending the service mesh.
Yeah, it's what we want to do here is, instead of having this case where all of these are running in a Kubernetes cluster, we only have some of them running in the cluster, and we don't care if the other ones are, right? So this is where we want to get at, wants to end up, where our central sorts of analysis and control loops and such might be running in the Kubernetes cluster on the left, but the instruments are probably just sitting out there. Maybe they're running Linux boxes. One of the cool things about the Linkerd proxy is it actually doesn't really care where it runs very much. It's the control plane for Linkerd currently cares a lot about running inside Kubernetes, but the proxy doesn't really care that much. It can run on just the bare Linux boxes. So This gives you the benefit, as Andrew was mentioning, you can use smaller, cheaper devices. You can, since you don't have to rewrite your application to get reliability and observability and security into it, it makes it easier to reuse your application in multiple places. And what we ended up doing was basically just running the Linkerd proxy and then doing some extra IP tables and routing on the Linux boxes. We are... I don't think we're going to show you the code that we used to get the proxy running. Come back in Paris and we'll have a much more elegant story on that front. But yeah, we do end up with challenges in this case, right? One of the challenges is Linkerd requires that all of these proxies share the same root of trust in the system so that MTLS works. That's a little interesting right now. Another one is you get to have a fair amount of entertaining fun with network routing and DNS and things like that. And I am enormously grateful to be able to stand up here and say, Andrew did all of that, and I didn't have to do it. But the really cool bit is that Andrew is not a Linkerd expert.
Not at all.
I am not a Linkerd proxy expert, really. So the fact that we were able to go and talk to the maintainers and find out how to do this without having to go and study for 6 months to be Linkerd experts is really kind of cool.
Yeah, so
what else do we have before demo time? We have nothing. It's demo time. Everybody.
So I'm going to switch.
Everybody pray to the demo gods. This is going to be interesting.
You know, nothing like the normal.
While he's doing this,
switching different networks and all that.
Yeah, while he's doing this, let me point out we have a Kubernetes cluster running in the laptop, and we have, what is this, a Pi 3?
Pi 3.
We have a Pi 3 that I'm kind of afraid to touch too much, that is running not Kubernetes, but it is running some workload stuff. Those are both connected to the same network, which is not the Wi-Fi, because never ever use demos. We use Wi-Fi for demos. But we have the laptop running on its internal battery, and we have our workload running on this external battery. So we are, in fact, doing Kubernetes and industrial applications completely on battery power on an isolated network, which is fine, right?
It works. Yeah.
Don't try this at home, kids.
Yeah. It burns through my laptop battery faster than it should, but that's...
Yeah, but that's your laptop.
Yeah. It would actually be a server. I didn't mean to... Whatever. Yeah, so what we've set up is basically I have a Kubernetes cluster running with Linkerd installed and the Emoji Voto demo, which I annoyingly didn't actually reset. So there will be a leaderboard here in a moment.
Darn.
Yeah, but it just kind of shows that like nothing's connected at the moment, right? And then I also have the Raspberry Pi running a tool called Cockpit that lets me kind of see what's running in Podman. I can do all the setup that I want. And basically all I'm going to do to set all this up is I'm going to apply this job, and then I will talk through it. And let's see if I can talk and type at the same time, which I already know I can't.
Riskiest part of any demo.
Cool. So that will go and run. And actually, it's probably already done by now. But in that, I'm going to scroll down a little bit. I give it some information that I want.
Oh man, you went and showed them all the stuff.
Yeah, yeah. You want to see?
Thought we weren't going to do that.
Really ugly bash. There's so many things that I just laughed when it worked, right?
Really what this boils down to is, hey, go and grab the environment that the proxy needs to know who to talk to.
And then go and SSH out to it and you know, yeah.
Yeah, about...
I don't like that I know bash that well.
I want to say about 80% of that is around moving certificates around, you know, so instead of going through all the complexity of setting up lots and lots of certificate management, we set up Linkerd, let it do the certificates, and then we steal them from the cluster and stuff them into the Pi, which don't do this in production, please. It's a very bad idea, but it worked great for a demo.
Yeah. So you can see that we have data flowing, right? The workload is voting on things. And to prove that it's actually going through the proxy, I'm going to go ahead and come here, look at the logs.
Wait, back up a second. You have the VoteBot running on the Pi right now, right?
Yes, the VoteBot is running
Okay.
on the Pi right now, and I don't know why those are.
The architecture of that demo, there we go, some of the numbers changed.
Yeah.
The architecture of that demo is that the VoteBot is picking a random emoji to vote for every couple seconds, I think.
Something like that.
And shipping, it's basically just doing a post to the voting workload, which is running in the cluster on the laptop. So we have something where the emoji VoteBot is running in the Pi, talking to the laptop, and then the laptop is showing you all this stuff. And I think now we're going to break that, right?
Now we're going to break that. And just so that I'm not having to like flip back and forth, we've got some logs that you can see that it's actually like continually voting. And if I come over here and pause the proxy container, it stops. If you let it go for long enough, it'll actually time out. And then if I resume, it goes again. Ta-da. I know. So it doesn't look super impressive, but hey.
We could also break it by unplugging the network cables, but I'm not sure I really want to do that.
I'm not completely sure if it'll come back up. Yeah, so just a real quick on like what the workload looks like that gets applied. Why is this not loading?
Because it's a demo, and we didn't pray enough to the demo gods. I don't know.
Oh, that's good. No, actually, hold on. VS Code broke, of all the things to break.
There we go.
Yeah, so the workload, YAML is we're using Podman kubeplay, and there's a init container that will run all the IP table stuff. There is the actual workload that we care about, and then the proxy stuff as well. And then a fun, like, I'm actually like using the kubedns as the DNS name server, is why not?
And as far as Linkerd is concerned, this business of being able to expand the mesh outside of the cluster is something that's under pretty active development. So come back in Paris, we expect to show off a much nicer demo that'll use Spiffy and not have horrible bash scripts and will just work, at which point we can tell you, hey, just go install Linkerd as a production thing and it'll be beautiful. But we can't do that today,
We're close.
which makes me sad.
Yeah, and then that's basically it for the demo.
Yeah.
Do I want to actually attempt to switch back?
I think we could just tell them.
Yeah. So kind of next up, I'm just going to let it see what happens. So kind of next is, so obviously making this production ready is, yeah, very obviously the next step. But then what I want to do is, I can't see it from my own computer. That's not what I wanted. Whatever.
Good enough.
It's good enough. Yeah, so the next phase is actually to integrate with Acri and Apinio. So Acri allows you to do device discovery and then run pods or jobs or really any workload when that device is discovered. So I'm going to install a MDNS responder on the Raspberry Pi and then build out a MDNS discovery handler so that when that Pi comes onto the network, it runs the setup job, gets set up and configured, and everything just goes. So then the next piece is I wrote a tool called Apinio a couple of years ago that gives you a Cloud Foundry, Heroku, Google App Engine style kind of platform as a service that's built on top of Kubernetes. What's really interesting about it is that the output, like what's actually installed, is a Helm chart that you can override. So I can make that Helm chart be the Acri configuration. So as soon as you do an Apinio push, it takes your code, it builds your code into a container, and then it reapplies the Acri configuration, which means that now you are able to just do Apinio push and then have that new workload show up on your non-Kubernetes device. And yeah.
Which will be cool.
Yeah.
Yeah. And I think that's it for
Yeah,
this.
yeah.
Do we have any questions? I think we have about 2 minutes for questions.
Questions?
All right.
Cool.
Either we glazed everybody's eyes over, or it actually worked out okay and explained it. Yeah, that's
Right,
that's
I'm
true.
hungry.
That's true. Thank you.
Thanks so much, guys. And yeah.
Thank you.
5 minutes.
Hello. We're good. Right, we're back. Okay, great. So a change to our advertised schedule. Shane is stepping into the breach to cover 2 of his colleagues who were unable to attend. So if we could have a standing ovation, please, for Shane Kumpf, our first speaker of the afternoon. Thank you.
All right, hello everyone. Quick mic check. Can you hear me all right? Excellent. All right, my name's Shane Kumpf. I'm a principal engineer with Cloudera. I was supposed to be joined by my colleague Sunil. Unfortunately, he had a family emergency and had to back out at the last minute. So what I'm here to talk to you about today is our journey towards KubeVirt. For those that don't know, I want to talk a little bit about who Cloudera is. So Cloudera, we're the creators of the big data industry and ecosystem, powered by open source software. Our Open Data Lakehouse product, CDP, enables portable cloud-native data analytics, helping organizations manage any type of data on any cloud, whether it's public or private. And what we found is that shipping an Open Data Lakehouse is challenging, right? Cloudera's Open Data Lakehouse is built on 30 different open source offerings. We do dozens of product releases every year. We support running CDP on nearly a dozen different Linux operating systems. We integrate with multiple databases, security products, hardware appliances, et cetera. And the result of all this is that we run hundreds of thousands of tests across tens of thousands of ephemeral clusters for every single release that we do. And so how we've met that demand to date is on a container cloud powered by Apache Hadoop Yarn. So myself, Sunil, and others, we're all Hadoop committers. We have a long history with Hadoop. We built capabilities to run Docker containers on top of Yarn. This provides an ephemeral VM-like container for product testing and development. It's fronted by a very simple API. The users specify resources like memory and CPU, the number of instances they want, and then what Docker image to run. We then orchestrate that across a collection of bare metal systems. And what's really important about these containers is each of these containers gets a stable IP and hostname. They have SSH running, and they have things like systemd running in the container. So for our users, this feels very much like a VM. They can SSH into it. They can install their software how they typically do, right? It feels like a Linux VM to them. And as a result of that, we've seen really high adoption over the past 6 years. Our production cluster is now 700 plus nodes. We have dozens of teams in queues where we split up the resources in these clusters. And at any given time, we have upwards of 1,500 clusters across 8,000 containers. And we're seeing an average memory utilization of about 80% on this cluster. However, after running the system for the past 6 years, a number of pain points have emerged. Containers are great, but we do have some VM use cases that don't fit into containers. For some of our certification purposes, we have to run custom kernels. We like to do Docker, right, and containers. Doing Docker and Docker at scale is a hard problem. And we have specific security requirements, things like FIPS, where we need custom parameters inside of these instances. We've also found that host maintenance is quite difficult. Our existing cluster is ephemeral in nature. These containers are ephemeral. If a host fails, a container fails, the state is lost, right? So that makes it very difficult to do host maintenance when you have to coordinate with all of the people that are running software on that system. Additionally, for people that don't know about Hadoop, when you run an application on Yarn, there's a small application that gets deployed along with it that manages the life cycle. At scale, that becomes a problem. That small overhead for every application is equaling 5 to 10 terabytes of memory on our cluster today. And then finally, Docker on Yarn is a feature that's not in active development. It's something we built years ago, so we wanted to look at other alternatives there as well. So we stepped back and started to reassess our options for this platform. But to do that, we really needed to think about what are our requirements. So first and foremost, we need a performant, scalable deployment of compute resources. We still want to support containers, right? We went towards containers in the beginning because of all their benefits. We still want to support those for those original reasons. We need flexibility on which operating system, kernel, security config happens per deployment. And we want very simple network connectivity. We don't want to have to deal with all the pod networking, all the proxies, et cetera. We want direct connections to these through stable host names and routable IPs. And then finally, improving host maintenance will improve user satisfaction if we can make it easier on our users so that they don't need to shut down their applications. So things like live migration and persistent storage become very important to us. And so we started to explore what's out there today. right? First, we looked at VM orchestrators, things like OpenStack, rolling our own with libvirt, et cetera. But the main challenge there is there's no support for containers, so we'd still have to bring some container orchestrator there. We then looked at newer versions of Apache Hadoop Yarn. Again, there's no support for VMs, so we have many of the same gaps we have today. We spent some time looking at Harvester, and it's actually really interesting. But it's more of a focus on VMs, and the thing that really scared us away from it is the entire stack is shipped as a bootable ISO. So we were a little concerned about the vendor lock-in that would cause. And so then we came across a solution called KubeVirt HCO. So HCO is the Hyper-Converged Cluster Operator. This is an operator you can run on your Kubernetes cluster that bundles multiple different operators, things like KubeVirt, the disk imaging that you need to get the VM images out there, advanced networking, DNS, a VM proxy, and more. And what was really appealing here is that it supports both VMs and containers. So it was a good fit for what we were looking at. So once we decided that KubeVirt was an interesting solution that we should spend more time on, we wanted to see how we could fit that into our overall architecture. So I'm going to spend a minute just talking about where we've landed. I'm not going to go into everything here. It's a bit of an ice chart. But I at least wanted to call out the main components that make up our new stack. So at its core, we're running a Kubernetes cluster based on RKE2, which is Rancher's RKE2. On that cluster, we've deployed the HCO, that operator, to manage the VMs. Underneath the hood, we use Longhorn for our storage for persistent volumes. And where we've done things a little bit different is we've adopted Apache Unicorn. Apache Unicorn is an advanced Kubernetes scheduler that does a lot of things that the default scheduler doesn't do. We'll talk a little bit more about that. We've developed a system internally inside of Cloudera called Umbra. Umbra provides us a quota management system on top of Kubernetes. How do you split up a Kubernetes cluster's resources amongst groups, teams, et cetera? Unfortunately, the out-of-the-box DNS implementation that comes with KubeVirt didn't meet our needs. As I said before, we wanted both pods and VMs to have that persistent DNS. What comes out of the box doesn't meet that need, so we built our own. I'll talk a little bit more about that. And then we use things like Prometheus for metrics, StackStorm, and AWX for our event and workflow system, and we built a custom API server that mimics that existing system we're coming from. We want that same simple API for people to get into this cluster as well. So once we looked at this and overlaid it into our architecture, it looked like it was a great fit. So we started to move forward with implementation. And we hit a number of challenges. And that's really where I want to spend the rest of the time during this talk, is talk about some of the challenges we hit and how we address those challenges. So we hit, as I said, we really want that stable IP address. That's different than Kubernetes. In Kubernetes, when a pod goes away, you don't know what IP address you're going to get. It makes it very difficult for existing systems that expect to run in a VM and bind to that address and keep that address for the life of the application. Similarly, on the DNS side, we need the stable name resolution for pods. There is something that comes with KubeVirt called kubesecondary DNS. Unfortunately, that only handles the VM side. As we started to provision things, we noticed that provisioning was extremely slow. We're used to, if an image is localized, a couple of seconds to bring up a container, right? As we move to KubeVirt, what you need to do is that OS image needs to be copied into a PV for every single VM that you run. That copy process was way too long for us. It just simply wouldn't work. Live migration was extremely important to us, but it doesn't look like it works out of the box. What do we need to do to make it work? And then finally, multi-tenancy. We have to have the ability to do queues, capacity guarantees, split up this cluster amongst all the different groups. So how did we address each of these? So the first one I want to talk about is the network architecture. So again, the gap that we had is we wanted to bind to a stable, routable IP address for both pods and VMs for external connectivity. And the way we address that is through 3 different pieces of technology. There's something called the NM state operator, Multis CNI, and the whereabouts CNI plugin. So the NM state operator was the first piece. What that allows us to do is manage the network interfaces on the kubelet hosts. If you're familiar with Network Manager, this is built on top of that. It allows you to then create additional interfaces on each of the kubelets. And it's all done through an operator. So somebody doesn't have to go into configuration management when they provision these machines. You can do it all through Kubernetes. The next is Multis CNI. So CNI is the container networking interface. Multis allows you to run multiple different CNIs under a single CNI plugin. And so by doing that, we were able to then create the network interfaces and bind them to the bridge. And then finally, because we're using routable IPs. We're not using the pod network. We needed to give some IPs, some routable IPs, that could be used to give out to these pods. And that's where whereabouts CNI comes in. You give it a pool of IP addresses, and it will hand them out to pods and make sure there's no conflicts, no IP conflicts. And so with these in place, we now have a stable IP that moves between containers and VMs. On the network, on the DNS architecture side, again, we were missing that stable name resolution for pods, as that kube secondary DNS only supports VMs. So what we've done is we've actually forked kube secondary DNS to add pod support. And the way that this works is that the zone file for core DNS is stored on shared storage. There's a sidecar within core DNS that looks for these virtual machine and pod creation. When it sees one of those, it creates a entry in the shared zone file. And then due to a setting within core DNS, auto reload being turned on, it will core DNS will automatically read any changes to shared storage and make those DNS records available. So from that, we have stable DNS names across both of those systems. The next issue we hit was around the VM provisioning times. And really that was about this use of something called a data volume. Data volume is what KubeVirt provides to copy that VM image into a PV so that you can boot that VM. Because we use Longhorn, there's already an existing capability in Longhorn called backing images. And they actually support QCOW2 images, so copy on write type of images. So we can take existing QCOW2 images, create them as a backing image inside of Longhorn, and then use that as our PV. Use that as our PV for the VM. So what this means is we don't have to do this copy operation. We use this copy on write image that, as long as it's already localized, will be mounted and starts up extremely quick. So we create a storage class for each operating system we support. So if it's CentOS 7 and Ubuntu 20, we have to have 2 different storage classes for that. And then when a VM comes up, it specifies the storage class for the operating system it needs. And then that will become a PV that is its persistent root volume. And this provisioning only takes a couple of seconds due to the copy on write nature. The next feature was live migration. So what is really needed to get live migration working for VMs? And what we found is there's something called the live migrate eviction strategy, as well as the need to use persistent root disks. So if you leverage that live migrate eviction strategy that HCO gives you, when you drain a node, it'll automatically live migrate that VM to another system. You get this for free with the out-of-the-box common VM templates. If you're doing your own custom templates, you have to include this. Additionally, you need a read-write mini persistent volume, because there's a copy operation that happens for this migration, for this live migrate to happen. There's also some work we're looking at in the future, because there is a copy operation, that means data is moving. If data is moving, that's moving across your network, right? So there's the ability to set up a data-only network behind the scenes for migration activities. This is very similar to how the VM orchestrators like ESX do it. And then finally, I want to talk a little bit about our quota management efforts. So how can we split up resources between different teams within this cluster, right? So Kubernetes exposes all of this CPU and memory. How can we split that up so that teams have guarantees that they have capacity when they come to use it? And our solution there is to implement a hierarchical resource quota system, right? And we're doing that using Cloudera's Umbra and Apache Unicorn. So I mentioned that Umbra is something we built in-house. It is a core component of our CDP offering, and it provides an API for defining a hierarchy of resources. You define a root with some amount of resources and then split that up into children, and then ultimately a namespace is tied to a leaf queue. And when you deploy to that leaf queue, we're going to use resources within that to make sure that you've got the capacity. Apache Unicorn is an advanced Kubernetes scheduler. So this is something that's getting a lot of traction right now. So it does a lot of things that the existing default scheduler inside of Kubernetes cannot do. So it gives you quota enforcement. It can do things like preemption. It has priority. It has the ability to do gang scheduling. Gang scheduling is extremely important for big data applications. Think about a Spark application where you have a driver and some number of executors running. If your driver is the only thing that gets scheduled, you never do any work, right? So you need to be able to schedule the driver and the executor together as a gang to make sure that you can actually do some work on a cluster. Kubernetes has none of that built in today. And so Umbra integrates directly with Unicorn to do all of the quota enforcement. So as we create this hierarchy of resources, we also tell Unicorn about those queues, and it does the enforcement behind the scenes for us. And again, it is doing it at the scheduler level. All right, so having talked a little bit about the challenges we've had, I want to do a demo that shows KubeVirt in action with some of the capabilities we've talked about here today. Is that visible? Can you see how this looks? Are you able to see? Yeah, all right. So the first thing we're going to do should look pretty familiar to anybody that's worked with Kubernetes for a while. We're going to deploy a pod using a pod YAML template. Very basic pod in this case. And then we're also going to deploy a VM. And this shows you how easy it is. With KubeVirt, you have a couple of custom resources, one being the virtual machine resource. So all we've done is define this virtual machine resource, this custom resource, and behind the scenes, the HCO and libvirt will then take this and create the VM for us. Here we can see that the pod is up and running in this cluster. It took about 12 seconds to get started. The VMs take a little bit longer, but with the improvements we've made, it's still a very reasonable amount of time to get up and running. So here we can see we're up and running. The demo VM's been running for 25 seconds. And note the IP. This is an IP that's not inside of the pod network. This is a separate IP that we've provided. This 10.17 range is the one we've given to whereabouts. You can also see that this particular VM is running on worker 1 within this Kubernetes cluster. So now that we've got those two resources deployed, we want to look a little bit more into the networking side. So first things first, we're going to look at the pod. So here, looking at a pod, we can see we've attached an additional network interface to it using Multus CNI and the work we've done on the networking side. And note the IP address. This is also part of that range that we've provided to whereabouts. So it's a 10.17.168.100 address. But you'll also notice that we've got the pod IP in there as well. So we're not throwing away the pod network, right? Everything's still accessible on the pod network. We're giving it another stable identifier that users from external to the cluster can use. And if we dump the same thing for the VM, we will see that that VM also has an IP on that same network that we've added through Multus. So now that we've got the IPs persistent, how do we manage the DNS side? And here we'll show that both of these get a name, or both of these get a persistent DNS entry inside of our cloudera.com domain with that whereabouts IP. So these are accessible from external. These names will not change. It gives the user a stable identifier to access. And so here's a little bit about the whereabouts config and how we're doing the attachment to the bridge. It's something called a network attachment definition. You'll see more about that as you dive into trying to do this. And then finally, we want to do an example of live migration. So here's that VM we stood up before. A couple of things I want to note. See how long it's been running, 8 minutes and 7 seconds. You can see the IP ends in 101, and it's running on worker 1. So at this point, we have initiated a forced migration. So this isn't the result of draining a node. We've asked this specific VM to migrate. And here we watch the status. And then it's finally succeeded. And now we want to look inside of that VM to make sure that the live migration happens successfully. So here we can see we're now running on worker 2. The IP has not changed. The age has not changed. Here we're SSHing directly into the container. and doing an uptime, and you can see that this container's been running for 8 minutes. So despite the fact that this was moved between systems, the IP remains the same, the processes still have 8 minutes of uptime, and everything has been successfully live migrated. And with that, huge thank you to the open source community. Clearly we can't do it without you. We really appreciate all the hard work there, and I'd like to open it up for questions.
Thank you, Shane. Awesome.
Thank you.
Round of applause, please. Right, questions? Any questions?
Yes.
We good? Testing? Yep. Just wondering, so you've got a fork of the secondary DNS operator. Did you look at the secondary, the external DNS operator?
So yeah, that is an option as well, and we've talked about that. The thing with external DNS is you have to talk to something external, right? This still kept it all internal for us without needing to have that external dependency.
Okay,
Yep.
fair enough.
But in Yarn, we actually run our own DNS server. So we wrote our own DNS server that manages it all at scale. So technically, yes, we could hook into something like that for our external DNS. Yep.
Gotcha, thanks.
Okay, any more questions?
Yes.
Thanks for the talk. On the topic of improving VM provisioning times, could you unpack a little bit how that persistent volume, how is that working? Are you basically using that as a golden image then for the subsequent nodes that you're putting in the cluster?
That's it exactly. So, and again, we're leveraging something that Longhorn gives us, right? The ability to have it's something called that backing image. So it's a little bit different because we're using Longhorn in that case. But what happens in that case, you create a backing image and then you create a storage class out of that. Every time that a VM uses that storage class, a new PV that uses that underlying QCOW image will be provisioned, right? So as long as the QCOW image is already deployed to the systems, it's extremely fast to get it up and running.
But are you then getting the same machine IDs across everything, or are you managing that in a separate way?
That's a good question. You're talking like your cloud init type stuff?
Exactly.
Yeah, that's a good question. I think that's all handled by
Longhorn?
libvirt internally. Okay. Yeah, because we're not doing anything specifically for that, any sort of cloud init type stuff. Yep.
Okay, any more questions, folks?
So it looks like tremendous effort have gone into this. Do you have any page where we all can learn, like do you have some documentation, somewhere wiki, some YouTube, somewhere being, okay, this is all the thing, all the struggles, and this is the solution, so that anybody else can, like us, can learn from it and see if we can implement the same thing in our company?
For sure. That's a great question. So this talk is kind of going on a roadshow right now, and I expect we're going to put out some blogs very soon that outline those details. So, yep, that should be coming to the Cloud Era blogs.
We don't want to reinvent this.
Exactly. No, and we want to share the learnings. I mean, we've been spending a bunch of time on it, so absolutely.
Okay. Any more questions?
So just curious on NM state, any tips for debugging the weird and wonderful joys of NM state as it starts to run into issues, maybe trying to configure a node network? Yeah.
Yeah, and we have had some problems like that due to we have a bunch of different hardware, right? And we've had some challenges around that. I mean, digging into the operator logs is about the state we went, and then getting down to the Linux systems. I mean, you know, we're I guess comfortable managing fleets of Linux systems, so that helps. Like we can get down and check the OS side and whatnot. But we did hit some conflicts because ordering of NICs, et cetera, was a problem on some of our systems. So I don't have a great answer there other than, you know, Linux troubleshooting and look at the operator logs, right?
Yeah,
so,
that's precisely where I'll be.
Right. No, it hasn't. It's powerful, but you know, with that power comes some complexity for sure. Yeah.
Okay. Any more questions? Let's have another round of applause, please, for Shane.
Thank you.
Thank you very much.
We appreciate it.
We will be back in about 8 minutes, I think. awesome. So welcome back, folks. So if you weren't in our last session, what we're doing all the afternoon sessions is going to welcome our speakers to the non-existent stage with a standing ovation, please. If you'd like to give it up for our next speaker, who's a very good friend of mine, and there isn't many people in the world who know more about open source and community than Dawn Foster. So please, standing ovation.
I feel like a rock star. I get a standing ovation and a fabulous introduction. So welcome to my talk, everyone. The slides are already uploaded both on my website, which you can find linked here, Fast Wonder Blog. They're also on the Cloud Native Rejekts site as well. I wanted to just quickly thank the Alfred P. Sloan Foundation for funding the Chaos Data Science Initiative, so basically paying for my work, along with some other Chaos initiatives and some funding from the Linux Foundation and the Ford Foundation that support the work we do in the Chaos project. I have been in the technology industry for over 20 years, mostly working on open source projects with a focus on community strategy, metrics, and growing your contributor base. And I can tell you that it's really hard to build a strong open source community for a project. Most of us struggle with finding enough humans to sustain our projects. So let's start by talking more about the problem and why it can be so hard to achieve sustainable contributor growth for open source projects. As I said, the problem is hard. I like to start this presentation with a Star Trek quote. So an alien life form on Star Trek: The Next Generation once described humans as ugly bags of mostly water. Now, I don't think we're ugly, so they got that part wrong, but we're pretty squishy, right? And not just in the physical sense, we can be unpredictable and irrational, especially when we're stressed out, overworked, or burnt out. And the reality is that we aren't robots, right? Or mindless automatons. Humans have feelings. We have bad days. We have other commitments and loads of personal challenges in our own lives that are often invisible to other contributors. And they can get in the way of our contributions to open source projects. But you can't have an open source project without having those human beings to maintain it. So you need to be able to encourage people to participate in ways that are sustainable over the long term, both for the project and for those individuals. And it helps to be proactive and ask people to participate in specific ways and in the ways that match the work that you need to do within your project. Many projects struggle to find people who will actively participate in their projects and continue to participate over the long term. If it was easy, you'd already have all the people you needed to maintain your project, and you wouldn't be here watching this talk. We're in a situation now where there are a lot of open source projects and just not enough contributors. Maintainers are burning out, and they're in desperate need of help. So sometimes it can be really difficult to get people to contribute to your project, and unfortunately, there is no magic or one-size-fits-all solution. But throughout this talk, I'll focus on some things you can do to increase the chances of successfully building a community and growing contributors for your project. Open source project maintainers are also squishy humans with feelings and bad days. Maintaining an open source project is hard work that often extends out over many, many years. And maintainer burnout is common in open source projects. Even the really big, successful open source projects like Kubernetes struggle with maintainer burnout and growing the contributor community. It can be hard for already overworked maintainers to balance the day-to-day work required to keep the project running, while also investing in additional activity to increase future community sustainability. This creates a vicious cycle where maintainers don't have enough time to onboard contributors, leading to fewer contributors, which leads back to no time to onboard new contributors. And while it takes a bit more time up front, if you can invest some time in activities that will help you onboard some new humans, like onboarding documentation, you can increase the chances that you'll break out of this vicious cycle. All right, now that we've talked about the factors that can impact contributor growth and why it can be so challenging, I'm going to shift into talking about some strategies for growing your contributor base using contributor ladders, for example, to help find more humans who can grow into leadership positions. And then finally, I'll talk about some metrics you can use to measure project sustainability, along with some resources and final thoughts. As promised, let's start by talking about developing and executing on a long-term contributor growth strategy, including motivation, governance, new contributor onboarding, mentoring, and leadership. People's motivations for contributing to your project vary widely. Some people are contributing as a part of their job, while others might contribute to gain experience or maybe learn about a particular language or technology. You don't actually have any control over what originally motivated these people to show up, but there are some things you can do to motivate them to stick around, regardless of why they showed up in the first place. Clear communication and reducing friction are key to helping people stick around. And I'll talk more in upcoming slides about the importance of explicit and clearly communicated governance, along with solid onboarding docs and fostering a welcoming and inclusive community. There are also other things you can do to motivate people to contribute. Having good first issues or help wanted labels are excellent places to start because these help the humans find something that they can work on while they learn more about your project. Good first issues should be targeted as something simple that a brand new contributor could pick up and complete in a short amount of time to help them learn more about the contribution process. Help wanted labels can be for issues that maybe are a little more involved, so the people who've already started to contribute can find something else to work on. But good first issues and help wanted labels are passive requests for help. So I encourage maintainers to be proactive and specific about ways that people can help. Asking someone specific to review a PR or answer a question from a user demonstrates that you recognize their unique expertise and want their help. This is what motivated me to start contributing to tag contributor strategy within the CNCF. Paris Pittman asked me to write a guide for the tag about measuring project health, a topic that admittedly I am pretty passionate about, and it made me feel good, right, that she recognized my expertise and wanted my help. Knowing that we're wanted and appreciated makes us squishy humans feel good, which can be a strong motivator to contribute to an open source project or to continue contributing. A lot of people like to hate on governance. Just extra paperwork, it's busy work, it's politicking that gets in the way of doing the real work on the project. But this isn't true of good governance, which is really just about setting expectations and getting all of the various humans within your community collaborating together. Ultimately, the focus of open source project governance is on people, the roles we play, our responsibilities, how we make decisions, and what we should expect from each other as part of participating in the community. The goal should be to make the processes for participating as obvious as possible, even for people who are brand new to the community. Having clear rules about how collaboration occurs, how decisions are made, what types of contributions are in or out of scope, helps community members make contributions that are likely to be accepted and embraced by the project. This helps avoid wasting maintainers' time with contributions that just aren't aligned with the project. A healthy project with clear governance makes the humans happy and helps set your project up for future growth and long-term success. Another aspect of governance is about making it easier to move people into areas of increasing responsibility to help reduce the load on the existing maintainers. Now, we'll talk more about this later in the section on contributor ladders and leadership. The good news is that you don't have to start from scratch. We have some really good templates with instructions that we've developed for the CNCF, but that apply to most projects to help you quickly and easily build out some basic governance for your project. Now, I suspect that some of you are still thinking you don't really need to spend time on governance, but think about this from the perspective of the new contributor. It's much more difficult to participate in a community if you don't know anything about the role you might play, the expectations, the key players, or the rules for participating. Explicit documented governance gives both new and existing contributors a clear path to guide them through your project. Spending a bit of time documenting governance up front can save you time later with fewer questions about how things work, and it gives you a document that you can point the other humans to if they have questions. When I start contributing to a new open source project, I want to know how decisions are made, who makes those decisions, and where the discussions about the decisions happen, which helps me understand whether the decisions are made fairly, in the open, based on solid information with the involvement of people with the expertise to make those decisions, And I also want to be able to see a clear path into leadership for me or for my colleagues if we decide to embrace the project over the long term. The bottom line is that if the processes for collaboration and decision making are not clearly documented as part of project governance, this introduces a lot of uncertainty into the mix. And uncertainty makes the humans nervous. It increases the barrier to contribution while also jeopardizing the health and viability of the project. Good documentation is how we scale the things that take up precious time for the already overworked human beings, like answering the same onboarding questions over and over and over. I see so many open source projects with contributing guides that don't actually provide much or frankly any useful information. At a minimum, a new contributor needs to understand how to spin up an environment where they can do their development, the expectations for testing and how to run tests, any processes or other expectations you might have for pull requests, and instructions for other requirements like a contributor license agreement or developer certificate of origin, for example. If this is all well documented, new contributors can get started with a minimal amount of help from existing maintainers, which can save you a lot of time in the long run. When a project doesn't have good onboarding docs, those squishy, burnt-out maintainers get frustrated by the amount of time they spend on new contributor questions, which can make it hard for new contributors to feel welcome and take a long time for them to become productive. And this is how the humans get discouraged and drift away from your project. This doesn't mean that you need to spend days and weeks writing the perfect onboarding documentation. Anything is better than nothing. And if you start with a few things that will help people get started quickly, new contributors can actually help make the onboarding documents better by adding more details and additional instructions for the things that they found confusing or that they struggled with. Your project should be designed to keep diversity, equity, and inclusion top of mind. Building a diverse community where all of the humans feel welcome and included doesn't just happen. It requires putting work and thought into it. But this is time well spent, right? Providing an environment where everyone, including people from marginalized populations, feel safe is the first step toward building a diverse community around your project. Ideally, having programs that give people opportunities for shadowing, mentoring, and sponsoring new potential leaders can help grow a diverse set of people into leaders within the project. The Kubernetes Contributor Experience SIG is a great place to see some examples of how to implement programs for things like shadowing and mentoring. Projects that make a concerted effort to bring in new people from a variety of backgrounds and have programs in place to help them grow into leadership positions are more likely to benefit from increased innovation and have a healthier community. By having a diverse and welcoming community, you also have the advantage of getting the humans who might not feel welcome in some other projects. Now, this is still kind of part of the strategy section, but it's important enough to call out separately with its own section, since moving new humans into leadership positions is a key part of growing your contributor base and scaling your project. And I'll talk more about this in the context of contributor ladders, which is a good way to do this. Defining the roles and responsibilities for contributors, reviewers, maintainers, and other roles can help with recruiting new humans into these roles. It can help to think about this as a ladder where contributors can climb up to become reviewers, those reviewers can become maintainers. What's important is to document it and make sure that people understand how they can climb that ladder and gain more experience within your project. A contributor ladder usually outlines different contributor roles within the project, along with the responsibilities and the privileges that come with them. Community members generally start at the first levels of the ladder and then advance up it as their involvement in the project grows. For each rung of the ladder, you can define responsibilities, which are the things that a contributor is expected to do. Requirements are the qualifications that a person needs to meet to be in that role. And privileges are the things that a contributor on that ladder, that level, are entitled to. And all of this helps set expectations for the roles and encourages people to think about how they might take on areas of increasing responsibility within the project. As you get more of the humans moving into maintainer roles, you can reduce the load of the existing maintainers. And the good news is that, like with some of the other things, there's a template you can use to avoid building this from scratch. Now, it was modeled after Kubernetes, so it probably has more roles than most projects need. So it's usually simplified and customized for what you need for your project. Project leadership is one of the key elements of good governance. And this is how you scale your project. So you should have clear documentation about your leadership. For small projects, maybe you just need a list of maintainers that indicates which of the humans are responsible for various areas within the project. But the key is to spend some time thinking about this as you document your governance and contributor ladder so that you can bring new humans into leadership positions and reduce the load on the existing maintainers to help scale your project by growing your contributor base. Now, there are quite a few different options for selecting leaders as part of defining your governance. And the ideal is to have a process that provides a fair and level playing field that defines how contributors become leaders. This should be documented, again, so that all participants can clearly understand the criteria and the process for moving into those leadership positions. Some of the bigger projects, like Kubernetes, Knative, have an election process, at least for the top levels of leadership, like a steering committee. But only the biggest projects actually need something that complicated. Most projects have a really simple process where the existing leaders get to select the new ones. For example, new maintainers are often nominated by existing maintainers and approved, maybe after a certain number of maintainers agree, or maybe there's a vote. And there are a bunch of different options for selecting leaders. I won't cover them here, but there's an entire document devoted to those options on the next slide, or sorry, on the link on the slide. Now, mentoring takes a bit more time, but it's a really good way to help existing contributors become even better, with an eye toward moving them into leadership positions. For busy maintainers, one good approach is to focus on mentoring some of the humans who've already been around for a while and are unlikely to disappear, to help them learn to do some more complex, time-consuming tasks. Now, like with many things, mentoring is not something that has to be all or nothing, and you can kind of time box it to whatever amount of time you can fit into your schedule. Even spending an hour a month or an hour a week to help someone quickly become productive in your project can be time well spent if that person can take on a few tasks to reduce your load as a maintainer. You can even structure this as shadowing to allow them to watch and learn while you do some maintainer tasks that you needed to do anyway. And if you focus this on helping another human learn to do something that can free up your time later, then this will be time well spent. Humans like to think of ourselves as irreplaceable. But we are not. We move on to other jobs. We burn out. We retire. And let's face it, humans are mortal and we do not live forever. You should think about what you might want to do next and how you can prepare someone else to take over after you move on. I encourage projects to have an option for people to move to emeritus roles, which recognizes the hard work that you've put into a project and gives others a point of contact if they have questions about what came before, while also allowing you to step away from some of the day-to-day responsibilities on the project. And I encourage you to think of stepping into an emeritus role as a successful way of handing your duties off to the next generation of maintainers for a project. The strategic part of all of this comes in thinking about where your time would be best spent. I've given you a lot of suggestions so far in the presentation, and you should not try to do everything at once. So I recommend you think strategically about where you should start. If you know you've had people interested in contributing, but then they give up when they couldn't get started, maybe you should start with onboarding docs. If you have a lot of casual contributors, maybe you focus on the contributor ladder and governance to help people to help move some of those other humans up to take on more responsibility and eventually move into leadership positions. Another way to free up some time for maintainers and break out of the vicious cycle that I talked about earlier is by getting help with different types of contributions that take up valuable time and are required to make an open source project successful. Documentation, marketing, community management, and lots of other roles. For projects with really complex code bases, it can sometimes be easier to onboard people into these roles first to free up some time to onboard other contributors later. One way to figure out the best place to start is by using metrics to help find problem areas and figure out where you should be spending your time. Time is precious, so it's important to identify problem areas where you can focus on the right things while avoid wasting time on areas that are already working well. However, metrics do need to be interpreted in light of how you operate as a community and the other things that are happening in your project. There's no one-size-fits-all interpretation of metrics. So in this next section, I'll use some example graphs from DevStats to talk about some trends that might indicate how you can think about addressing potential issues. You should also have a look at that project health guide from Tag Contributor Strategy. Oh yeah, it is linked at the bottom there, for more ideas about how to measure the health of your project. One key area to look at for your project is responsiveness. Projects that are responsive are more likely to retain both new and existing contributors. This graph helps you see if a project is keeping up with incoming pull requests. This is important for a couple of reasons. Old pull requests sometimes stay around for too long because maintainers don't want to tell someone that their pull request is just never going to be accepted. Often for very good reasons, right? Like architectural incompatibility or other conflicts with the direction of the project. But this leaves contributors hanging and unsure about why their request isn't being merged, which wastes people's time and reflects badly on the project. In this case, it might help provide some training for maintainers about the importance of closing pull requests and how to do it with empathy and kindness toward the people who put in the work to contribute. If even good quality, relevant pull requests aren't being merged in a reasonable amount of time, this can indicate that the project just doesn't have enough maintainers, or that these maintainers don't have the bandwidth to keep up. After a while, it becomes impractical, right, to merge old pull requests, because they're often just there are going to be too many merge conflicts if that pull request has been sitting around for months. So in this case, it's important to look at ways to bring more people into the project or to promote a few people to maintainers if you have existing contributors who are ready for that responsibility. Now this graph looks at time to first response to see if pull requests or issues are responded to by another human, excluding the bots, in a reasonable amount of time. Because a quick response can help you retain contributors who otherwise might become discouraged if they don't receive a timely response. In this case, the median is about 16 hours, which is pretty good. And this is important because people put a lot of work into a contribution, and they're likely watching that PR and waiting to see how it's received. If it sits there with no response for days and weeks, people get discouraged and they feel like they're wasting their time. In this case, any response is likely better than no response, even if the response is to thank them and give them maybe an idea of when to expect feedback. And again, if people aren't getting a timely response, it may be time to bring in more contributors or promote a few of those to become maintainers. Timely, thoughtful, and kind responses to contributors indicate that you appreciate their work. I also like to look at contributor risk for a project. This is often called the bus factor or lottery factor and can be used to think about what would happen to a project if a key contributor won the lottery and retired on a beach and never came back. In the Cilium and Cloud Custodian examples on this slide, the project would likely be okay if a couple of people left because the work seems to be distributed among quite a few contributors. If you see that one or two people are making all of the contributions, then it's probably time to find a few more contributors and mentor them into maintainer roles to better distribute the workload and reduce the risk for the project. Another reason that I like this metric is that you can also use it to think about which up-and-coming contributors might be ready to move into maintainer roles or be a candidate for mentoring to move into a maintainer role later. Before I wrap up this talk, let me leave you with just a few resources that you might find useful. The CNCF Contributor Strategy Technical Advisory Group has a governance working group, a contributor growth working group, and we provide templates and guidance about contributor experience, sustainability, governance, and openness, and help people develop strategies for maintaining healthy projects. We also have a contributor growth framework document that you might find useful. The Open Source Way guidebook has loads of details about building and maintaining open source projects. The Chaos project, where I work, has loads of metrics definitions and software that you can use to measure the health of your open source community. And these are all really great starting places for understanding how to grow your contributor community. Now, I've mentioned the CNCF Contributor Strategy Technical Advisory Group and linked to our resources on a bunch of slides, but I wanted to put in a really quick recruiting plug because like with most open source projects, we are also looking for help. The resources and templates that I've linked to were all created by the humans behind the tag. And we can use your help to improve them and create new resources to help CNCF projects. So if you're passionate about contributor growth, governance, building community, and want to help CNCF projects improve in these areas, we'd love to have you join us to help us develop more resources and provide advice to projects. So let's wrap things up, and I'll leave you with just a couple of final thoughts. Maintaining an open source project is so much work. And there are so many maintainers who are overworked, exhausted, and burning out. The best way to address this challenge is by finding more humans and growing your contributor base. But again, it's hard work. And it takes time away from the day-to-day activities now, which can be hard to justify, right? When you feel like you're barely keeping up as it is. In the longer term, spending at least a little time on things that can help you recruit and keep new contributors will be worth it. As I mentioned before, you don't need to do everything at once. Spending just a little time on something to grow your contributor base is a great way to start. So this is what I'm asking you to do. If you're a maintainer or even a regular contributor to an open source project, carve out 1 hour a week to improve your onboarding docs, your contributing guide, project governance, or maybe just spend that time helping another human learn to do something new. With that, thank you, and I'll open it up for questions.
Okay, questions for Dawn. Marginally quicker getting his hand up there.
Hi, Dawn. Thank you. I have a question around the maintainers' engagement and PR reviews.
Yeah.
And can you, you said like to do like a training to the maintainers so they can review. Do you have some ideas there? And a follow-up question around that. If the project is open source and let's say it's CNCF, right? But still some companies are behind it and they're heavily influencing the project. Some PRs which are not coming from the company originates the project can be moved forward quicker than the others. How do you have some ideas how to mitigate that thing? Because sometimes the company priorities are higher and they're driven faster in the community, and the community things are not that much of attention, right? You know what I'm talking about. So do you have some ideas how we can overcome this one? Because a lot of projects are facing these kind of issues. Thank you.
Yeah, I mean, so I think that it does take a deliberate effort, especially in some of those projects that have a lot of contributors from a single company. They really do need to make the effort to focus on some of those contributions that aren't necessarily coming from their company. Because the reality is that's how you scale your project. You're not going to be able to, continue to keep putting more and more resources from your company into it, into infinity, unless you're a very, very, very big company. And even in that case, probably not. So you really do need to, I think, make a concerted effort to make sure that people focus on some of those contributions that come from outside of your company. Does that answer your question?
I'd like to dig more. What's that effort in particular like? Because I'm community manager of a few projects and I'm constantly trying to educate maintainers that they have to do that.
Yeah.
But that doesn't happen for many reasons.
Yeah. So the
what else I can do, right? That's my.
Yeah, I mean, I think what you have to do is to continue to mentor some of those maintainers, and in some cases, especially when it's like a CNCF project, you do really need to stress that this is no longer a company initiative. That this really is bigger than the company, and they need to treat it that way. And those can be hard discussions to have with maintainers for sure. Yeah.
Thanks. Thanks for the talk. Just a quick question. I'm a reviewer for etcd, and one of the areas where I have a difference of opinion currently with some of the maintainers is around issues going stale and PRs going stale.
Yeah.
I think we should be trying to actively close down and respond to some of those and kind of triage those, and some of the tech leads and maintainers kind of think that it's okay just to let them go stale and kind of not respond, even when I think they should.
Yeah.
Any suggestions on how I approach that and trying to get that change across the line?
Yeah, I mean, I think that a lot of times we get caught up in the fact that we just have a lot of stuff to do, right? We've got code to get out, we've got features to merge, we've got all of this development work that has to happen, and you tend not to think about the fact that there are people behind all of these contributions, right? So I think it can help to stress to stress the fact that there are people who made these contributions, and it's only polite to respond to them. So I think some of that is just reminding people that they need to be kind and empathetic, and by actually treating those people really well, then you can get them to continue to contribute in your community. If you just let their stuff go stale and nobody ever looks at it, they're not going to come back, right? And I know etcd in particular has had a problem with recruiter or retainment of contributors. And you need to treat people really well. And it's hard, especially when, I mean, we get busy, right? And then we get short, we just try to get stuff done. And so I understand this problem. It's something I think we all face. But you really do need to be, I think, kind and empathetic with these people and encourage them to come back. And you don't do that by just letting their stuff go stale and go away.
Okay, one more round of applause for Dawn, please.
Thank you.
Thank you very much. I will just have a quick couple of minutes. ready to go again. Right, if you are just joining this room for the first time this afternoon, I've invented a new thing we're going to do where we're going to give a standing ovation to all this afternoon's presenters for all their hard work in coming here to speak to you. So our next speaker is Ben Hirschberg, and so if you could please be upstanding and give a standing ovation for Ben.
But you haven't heard of my presentation yet, so at the end, please. Okay. So hi, everyone. Sorry, this is not my computer. So sorry, I had some problems with my computer. I left it at the airplane, so I'm using not my computer right now. But hopefully the presentation is going to be okay. So just a few words about me. It's not that interesting, and we don't have a lot of time. I'm Ben. CTO of Armo, cloud native security company, maintainer of KubeScape, and contributor to different other CNCF projects. Also, like all around here and there. I really thought how to start this presentation today, and you know, we are going to talk about eBPF. I hope it is not a surprise for you after reading the title. But like, you know, there are all these presentations where, you know, eBPF is the medicine for everything, and eBPF solves all of your problems. And I wanted to start with this, and then I said, well, I want to start with something which is more practical. How do we solve problems? And I got to the security problem of configuring things around Kubernetes clusters properly in a secure way, and how usually sometimes lack of knowledge of how applications are behaving are a problem, and how we can use observability to solve this problem. So what we're going to talk about today is how we are going to how we are going to improve our Kubernetes workload security by looking at observability data from eBPF. We'll see how we are going to generate network policies based on eBPF behavior analysis, how we are going to generate second policies, and we'll also talk a few minutes about how to handle vulnerabilities. But in general, the whole idea, whole philosophy of today's discussion is how we can use deep observability in order to do our work better. Things that seem to be very hard and very time confusing, how we take two data streams together and make sense of it much better than before with it. So I hope at this conference this is not a surprise. Least privilege principle as from a security perspective. So least privilege is the idea that we are giving to every actor the privilege it needs to complete his job and nothing more. And this is what we are trying to achieve when configuring workloads. So as we are continuing, again, I'm returning, we are going to talk about workload configurations, pods, network policies, second policies. The idea is that while we're working in these environments, we are running applications in Kubernetes or maybe outside of Kubernetes, and we can see how they behave, what kind of operations they're using, what are their interactions with the Linux kernel, and using this information, we can start to fine-tune the definitions of our applications. And the way we are doing it in my example, and what I'm going to show you today is actually not a product, it is more of a research we are doing in order to do some product, is a way to detect these behaviors, and we started by using Inspector Gadget, which we have the representatives of the projects are here sitting here among us. It's an awesome project, and it enables us to make eBPF observability very simple, very, very easy to use. I suggest you looking into to this project. The way it works, it installs node agents on Kubernetes nodes and streams out different data streams, file access, network connections, process information, capabilities, system calls, all those informations are getting back to us users. Now, after a while, we started to work with it, and then we got to a conclusion that right now what fits us better is a little bit different approach. What we did is we took Inspector Gadget, built upon it an implementation of how to turn these eBPF informations and data streams into Kubernetes custom resources. And we created this application profiler for KubeScape, KubeScape App Profiler, which is a lab project for us. And what it does, it wraps around the Inspector Gadget and takes this information from all these pods which starting on Kubernetes nodes and turn them into these objects we can easily consume by a scripting. Now, the way you can install the KAP profiler is really simple. It's just to apply with kubectl, and it starts to run on your node, and it starts to create these CRDs which look like this. And I'm sorry that it's super small. I'm not sure that you're seeing that right now, but the general idea that you have this application profile object, which contains these different aspects of the workload, capabilities it uses, the DNS requests it does, the processes it runs, and like if we have more screens here below, you would see the rest. But in general, the idea is that you see all these data streams aggregated into one object. It was very, very useful for us because we use KubeScape, and again, full disclosure, I'm one of the maintainers of KubeScape. We took the KubeScape scans as objects, and it was very easy for us to take the application profiles as objects, taking these two data streams objects together, merge them together, and make more sense of the results. So, to show you what kind of things we've been playing with and start to work on it, is these are on these main security issues around workloads. What kind of kernel privileges the workloads are using? What kind of file access the workloads have? Whether they are talking to Kubernetes API. And there is an inherent importance in securing and tying down the workloads to use actually those privileges which are actually in use. So you don't want every workload to have Kubernetes API access. What does it mean? That you don't want to automatically everyone have an access token for service account token for the Kubernetes API, because if an attacker is able to penetrate the workload, it automatically has access to the Kubernetes API, regardless whether this workload was intended to talk to the Kubernetes API from the beginning. So I'm taking this example as the first one, and I'm running KubeScape scan, which essentially what it does, it lists out all the workloads in my Kubernetes cluster, which have access to the Kubernetes API through the service account token. In my case, I took the screenshots over the first one. I've used the the Google microservices demo application. It has a deployment called payment service. The payment service has a problem that it has an automatic mapping of service account. And the question is what I'm doing with this information. I have a cluster. I'm managing not one cluster, but multiple clusters with multiple applications. And I get such an error. How do I know what should I do? Now, so the tool says that, okay, you should make this property false. You should say to Kubernetes not to mount the service account token. But we don't know if the application uses that or not. Now, what can we do? We can start to make phone calls, or sorry, no one does phone calls today, but we start to write Slacks and Discords and open up GitHub issues. And what we see is after a while, we get information and we said, okay, safely we can turn this off because this application doesn't use it. Or someone will say that it uses that, then we have to leave it as is. But what we said that if we're taking these application profiles, and remember I told you that the application profile has the information what kind of files were opened inside the container, right? And if I'm looking, and this is this list within the application profile of the files that were open. If I'm doing this very, very simple grep over the application profile, whether the var run secrets Kubernetes IO service account was opened, in the first case, I don't find any access. In the second, I do find, you see one here, I do find access. These are two different application profiles. One is touching the service account token, the second is not. This means that I can use the eBPF information, the observability information, to safely turn this on and make a decision about this security issue, right? So again, I'm reiterating the idea. The idea is like trying to make sense, using eBPF, trying to make sense of all of these problems and trying to sort out really fast. Obviously, you can do it the hard way, again, reminding you Slack, Discord. But the time we invest in these kind of things is like enormous, and most of the time we are just not attacking these problems because we don't want to go down that rabbit hole. Another example here is another control which is telling us whether a workload has a mount from the host within Kubernetes. This is obviously have multiple issues with mounting host directories into a workload. Sometimes for some applications you must have, mostly administrative-like applications must have this thing, but most normal applications, usually there is no reason to do that. And again, Kubescape scans, it puts out actually the profiler workload which we're running. It says you have like multiple host path mounts, which is not a good thing. What can we do? We can again list out what are the files which were touched by the workload, and again trying to grep it out manually in this case, trying to see whether these host paths are indeed touched by the application. If they are touched, then you have to ignore this issue. You have to create an exception, say, well, this is a must. This is how the application works. I cannot do anything about it, and it's okay. But if it is not touching, then you can lower your attack, decrease your attack surface in a very easy way. And it is very, very important. Now, the third example is we are leaving the realm of files. We are going into the examples of Linux kernel privileges inside the workload. So another Kubescape control tells you, lists out which workloads have insecure capabilities, like which are the very, very capabilities which are giving huge privileges to the workload. Again, which can be, if an attacker is getting to the execution context, can use it to elevate its privileges beyond what should be. Now, again, we're exiting with some ideas of what the problem is. And Inspector Gadgets is a way to give us information about what kind of capabilities are actually used during the runtime. And therefore, the couple file logs it into the object. And then we can list it out which capabilities were actually used during the runtime of the workload. And again, take this information into a place where we can make sense of the control failures. This is something that is, to be honest, we found problems with this, and we have to sort out those problems. But in general, it is, again, very, very important to use the least privileges approach in this kind because these capabilities can give a huge advantage to an attacker. So I think that we are stopping here with the screenshots. We're going to go over. I just don't want to repeat myself. I think that the idea was clear. I think that, again, the general idea is that we are trying to merge different data streams in order to make our life much better, and to see that actually we've played around with this with our own components at Armo in our production environment just to see how it sorts out, and it was like within a day we're like being able to just playing around with this kind of stuff, lower our control failures by I think 80%, and it was just amazing. Now, what we are going to do is we are going to turn this idea into actually a product, and we'll add them to our offering. So it means that currently all these issues you can see and you've seen before can be covered using these data streams. So all these kind of control failures like all privilege escalation, read-only root file system, automatic mapping of service account tokens, which you just seen, and all the others can be covered using these data streams and can be automatized and can be made very, very safe to implement. Now, another two things which we used, and for this we used directly Inspector Gadget. We moved to full network microsegmentation in a production system. And we did that with simply using Inspector Gadget Advice feature, which is tracking the network activity on the Kubernetes nodes, and it compares it with the actual pod names and the pod IPs. Therefore, we can generate Kubernetes native network policies, and it just worked really good. There are like a few caveats. For example, going to where our backend is going to GitHub, and the GitHub endpoint is obviously a problematic thing because we'll hit different IPs over the time because they're using IP range. So this was something we needed to correct manually. And obviously, we had also AWS endpoints we were hitting, which had the same problem. But in general, from the pod-to-pod communication perspective, this worked for us very nicely. The second thing, and sorry, just I forget. I wanted to show you also that installing Inspector Gadget is super easy on your cluster. Like if you have crew, it's literally 2 commands rolling out Inspector Gadget. And I think it's something worth trying to play with and see how it works. The way generate network policies with Inspector Gadget is twofold. One is that you are recording the actual network events, and after you've recorded the network events, you are like translating the network events into actual Kubernetes native network policy. My only concern with this approach that we were actually monitoring our production system, for example, for a day, and some of the pods already left the cluster by the time we generated the network policy, so their IPs weren't resolved to pods. Pod names, and it was something we needed to do manually afterwards. I think we've covered here everything. I think the other thing that would be really nice is to have support, and we heard it from a few people, that there needs to be support for other kind of network policies, not just Kubernetes native network policies. So Cilium, Calico, and stuff like that should also be entered to make it more usable. Actually, as I see, like most of the people are not using Kubernetes native network policies, but using more advanced policies than that. The second thing we did for our production lockdown was actually attaching SecCom policies for our public-facing workloads. Again, we used the inspector gadget advice capabilities for that. Just a quick test here. Anyone raise hands here who knows what the seccomp policy is? Yes, you don't count. So, just in 2 words, seccomp policies is a way to limit processes in Linux of making system calls. You can configure the seccomp, which is a Linux kernel facility, to block different system calls. And the idea when, I don't know, historically I might be wrong, but when Docker defined the basic feature set, I think it defined that seccomp policies can be attached to containerized processes. And you can give it a list of system calls that you allow to a container to do. It is an awesome protection, a way to protect your workloads. When a workload is limited in the system calls to things that he actually can, system calls that it must have to do, any kind of new process will have a hard time behaving under that rules. And especially if you're looking at most of the exploited kernel issues are usually belonging to system calls which are rarely used. Therefore, usually applications don't need that. And if you're able to, if you remove this capability, attackers have also a hard time to escalate their privileges through kernel exploits. So it's an awesome way to protect workloads. The problem is that it's really, really hard to configure. Like any application developer, if you're asking what system calls your application is using, usually will look with these blank eyes and won't understand what do you want from him. So the way to use eBPF to understand what system calls an application is doing and turn it into a policy is a really great way to implement such a lockdown. My I think among all these challenges I'm seeing here, is the most problem I had today is the last one. So if the seccomp policy is not permissive enough, and you missed some kind of system call during the observability period, you will have really hard time understanding what the problem is. Like the application will just have a random failure and you won't understand. It will take a long time to debug it and understand what the problem, especially if it's a third-party application. So again, I'm a big believer of seccomp and really hoping that all the tooling around it is going to be much better. You can see the Kubernetes security policies operator. I think it's one of the greatest projects which tries to make seccomp policies as a first-class citizen in Kubernetes, and it's really a good thing. The last thing I wanted to talk to you about is another project which we are doing for a year, is using eBPF to improve static image vulnerability scanners results. So if you have scanned images, I don't know how many of you scanned images. I don't want to again to raise hands here, but so every one of you seen results of image scanners. You can see that there are not just tens, but sometimes hundreds of vulnerabilities. And I can tell you, as someone who's coming from the security realm of the world, I can tell you that in less than 0.1% can be really exploited. It means that most of them are false positives. And it's really, really hard to manage them. And what we did, again, based on the Inspector Gadget project in Kubescape, is actually we are using the file access information we have on a pod to see what files were used during the pod's runtime, and take the SBOM of the image, see what of the software packages were opened during the runtime of the workload, and mark them as in use or reachable, and filter out all those who are not. And if we feed this filtered SBOM into the vulnerability scanner, We have less than, it depends, really depends on the image, but of thumb is we have 80% is filtered out, and it's magic, and it's in the grasp of our hand. So it's something that really helps all those people who are actually day to day. What they're doing is they're working with vulnerabilities and trying to fix them one by one and evaluate them. Okay, whether this needs a fix or we can live with that and so on. And if you can say that only 20% of those vulnerabilities you have to deal with, it's already a huge step. It's a little bit promo time. I'm going to give a talk about vulnerability scan result prioritization in KubeCon. So if you're interested, you are welcome to join. So this was my talk for today. I hope it wasn't too fast. It felt really fast. Hope it made sense. Any questions?
Thank you, Ben. You weren't too fast. You were bang on time.
Yeah, I tried to.
Right. Questions?
Yeah, thanks for the talk. It's a kind of a side question related to eBPF. There is a lot of new tooling using eBPF. So how much can that impact the server, the workloads, having like your system, but many others all using eBPF at the same time for observability metrology, observability security, observability this and that,
yeah.
and maybe like service mesh and network stack.
Yeah. So I talking about the effect of eBPF on our CPU load is like, it's such a broad question, and I will try to really take it to parts. Everyone knows, and Liz can comment on that. I feel bad answering this question. You're in your presence. So there are things that eBPF showed that it can improve the performance of applications like network routing. There is no question about that, and there are multiple reasons for that. And everyone who built in his life network stacks in Linux understands that what is the problem. You can see different detection tools. I don't know, for example, Falco, okay, which are there to detect runtime issues. Attacks. You can see that they are eating up your CPU like hell. And I tell you something, it is not eBPF who's eating up. It is the design of how Falco was, the whole design of Falco was built, that all the data is streamed for eBPF, and there is a rule engine which eats up CPU in the user space very much. So it's not the eBPF part actually that it's very very CPU intensive, but as a result, the user space part. But I can tell you that obviously if you have high volume events from eBPF, any kind, either for the application profile inspector gadget, and you'll attach to it something that it is triggered by these events, it has to send over the network of them, or I don't know, it will have a very performance effect because there might be a lot of eBPF events. So I hope.
Yeah, thank you.
Okay, I think we've got time for one more question. Any more questions? No. Okay then, another big round of applause for Ben. Thank you very much. Okay, I think we're just about ready. So if you're just joining this room for the afternoon session, we're welcoming all our speakers to the stage with a standing ovation for taking part in this awesome conference. So if you would please be upstanding and give a big round of applause to Sebastian Thomas.
Yeah, 1, 2. Okay, thank you. So we're here to talk about limits and throttling. So we'll try to make that interactive. So who knows what limits are in a Kubernetes or a container? Okay, few of you. Who knows what is throttling about limits and resources? Not much, not sure. Okay. Okay. So I'm Sebastian, usually called Prune on Slack and whatnot on GitHub. I'm co-organizer of Kubernetes, CNCF Kubernetes and Canada meetups in Quebec, sometimes Montreal. I'm new cohort from the CNCF ambassador. I'm a contributor to our open source software. So the agenda, again, what are requests, what are limits, what that means for Kubernetes. Do I have an issue with my HPA because of that? So for the one who knows, it's like when you deploy something like a deployment stateful set, whatnot, you can actually, it's not in the deployment itself, it's in the pod, it's in the container section. You can define requests, so what my pod wants, and limits what my pod can use or my container can use, actually. So we're not going to talk about requests first, but that's totally it. And there's a catch I want you to know. Request, usually you think of request like, okay, my pod needs 100 meg of memory to start, or 2 CPU to start, because I know I need that full time. And you're just thinking that's what you need. Actually, what you request from the system level is guaranteed. So if you request, like, I want 2 CPUs, you're going to get 2 CPUs. Whatever happens. If you need them, you're going to get them. So that's one of the conclusions, but like I'm giving you that straight. Be very mindful with the request, because like it's a guarantee. You have it. So it's not just for starting the container. And then you have limits. Limits or quotas in the Linux kernel. It's what the container can use. So for memory, it's very easy. Memory, if you use more than that, you're going to be killed. Because the system thinks you're getting crazy, using too much, and you're out. For a CPU, if you use more than that, you're going to be throttled. And that's the content of this talk today. So this is a little bit nerdy, but everything that is tied to limits and requests actually goes down to the kernel and to C groups and how you configure that. So it's a way to tell the kernel what to do and what to give to the pod compared to what exists in the system. So this is very nerdy. You don't have to know that, and you will probably never go down to the system and look at that, but it's actually tied down very close to the kernel. So how limits are working? So that's the fundamental. So you think your pod is going to use like, let's say 2 CPU. So you say, okay, limits 2 CPU because my pod is very CPU intensive. I need 2. So what is happening in the system is you're not going to get 2 CPUs straight away reserved for you and whatnot. In the kernel, the CPU time is split in 100 millisecond sections. And when you define a request or a limit, or actually not a request, but a limit, you get some part of some time during this section. So here you have the quota, like if you use 1 CPU, you get the usage of 1 CPU during 1 period. Or you can also get like 2 CPUs, but half a period. Or if you use 2 CPUs, well, you can have like 2 CPUs for 1 period. Or I get, you understand now. If you set like half a CPU, well, you get half a CPU, and that's exactly it, what you get. But again, it's tied to 100 millisecond period. So these are like just examples. Your container is working for 200 milliseconds. You have 2 threads. You give it 2 CPUs. So yeah, it can work like your 2 threads are going to work concurrently during 100 milliseconds. That's what you're going to get. So actually, if the load is steady, you're going to get actually running here and here and here and here and all the time, because you're consuming 2 CPUs fully, one thread on each CPU. Or maybe you're not consuming all that, and then your 2 threads are one after the other. Or if you say, like my container, my limit is 1 CPU, what you should be using is actually the first thread is going to use the first period, and the second thread is going to use the second period. Okay? So now your workload, if you're working for 200 milliseconds, but only on 1 CPU, the work of your application is going to be done in 200 milliseconds. Okay? So by setting this limit to low, you're actually forcing the application to take longer to execute. This is just like a demonstration of the thing. So again, if you set the limit to half a CPU, then you're going to have half a period. So you're going to use half the period, and then you have to wait for the next. And half a period, you wait, half a period, and you wait. So actually, if you set the limit too low, your application is going to take 400 milliseconds to execute. So now your application is impacted. It's working slower than it could because you set the limit too low. And that's what we call throttling. Because your application doesn't know about these periods and whatnot. Your application wants CPU. Your application is saying, hey, I need CPU to compute something. And so the application doesn't know about that, but the system does. And the system is going to schedule you on 1 CPU for a period. And then once the time you had on the CPU is used, it's going to say, whoop, stop. You can't work anymore. You don't have any CPU anymore. And you're going to wait. So throttling is actually wait time for the CPU. And it can go like way worse than that. Let's say, oh, I have 2 CPUs. Okay, but if you set the limit very, very, very low, like 200 milliseconds, 200 milli-CPU, that means like, let's say 20% of a period, but you're using 2 cores. So actually, you may use 20 milliseconds on 1 CPU, but if you use 2, you will be only able to use like 10 milliseconds of a CPU plus 10 milliseconds on the CPU. That's 20 milliseconds of CPU, and that's all your quota you have. So then you wait. So now your application, still same application, is 500 milliseconds, half a second to execute the exact same amount of work, just because you set the limit too low. That's a recap, but I get you guessed that. So pushing the limit. So the idea is, if you want to set limits, you need to know your workload. You need to understand how your application is working. So generally speaking, I came out at the beginning with 3 kind of application, and finally I said, okay, this one is irrelevant. You have 2. You have the CPU intensive one, like you're running a batch. So your batch have a lot of data to compute, and it's going to work full CPU until the job is done, and then stop. And then you have the burst model, where let's say a web server, like if you don't have any request, web server is doing nothing. And then you get a request, you have to process that, compute something, generate a web page, send that back, and you're done. So that's kind of burst. And most of your applications are actually CPU bursts. And we could actually put the CPU intensity inside a burst, but the burst is long enough. So that's 2 kind of applications. So in real life, what's happening is that your application is using some of the CPU and then a lot of CPU, because most of the applications are multi-threaded, and you usually don't have any control of that number of threads and how many are used at the same time. So usually it looks like that. Okay? So it's kind of unpredictable, and you don't know about it. Because when you do observability, you may grab the CPU usage of your application every 30 seconds, 1 minute, or something like that. So you don't see this spike. What you see is a mean value here, somewhere in the middle. So you think, oh, my application is using 1 CPU. So I will set limit 1 CPU. But your application is actually not using 1 CPU. It's using like 5 CPU here, 6 here for this time period. And then 1. And probably 0 at some point. So you actually don't know how your application is really behaving, and that is pushing you to set the wrong limit value for it. And you end up with that. This is one of my clusters, ops namespace and kube system namespace. So it's only things I manage as a platform DevOps engineer. And you see 20% throttling for this terminated pod garbage collector, 15% for the stack driver exporter. So I'm badly doing my work actually because of that. So I built a small Go application. I'm not a very great Go developer. This is totally, you understand. It's an application that have 2 periods. One period where it's going to consume some CPU, and one period where it's going to consume, let's say, less CPU, the wait period. So that is supposed to mimic some kind of batch application where you process a batch and then you're done, and then you process another batch. The goal here is just to confirm how the limits are working in a repeatable way, reproducible way. So this is what it is. Like so because of the latencies on the metrology, on the scraping, it should be a straight line here. It should go from like 100 milli CPU to a full CPU. It should be straight, but because of latencies and mean values and whatnot, so the form is not ready. Who thinks this application is behaving normally? Who thinks this application is working fine? Who thinks there is a problem with this application? Yeah, you guessed it. Of course there is a problem. That's too obvious. Okay. Now, if you see this graph for the same application, again, for the previous graph was CPU usage, okay? This one is CPU usage versus the throttling person, and it's a rate. Do you think there is a problem here when you see that? Who thinks there is a problem here? 1, 2, 3, 4, a few. Okay, who thinks it's totally okay because it's the same graph as we had before for the CPU? Well, this is a very big problem because as long as the throttling is above 0%, that means it's happening. That means you're going prevented to use the CPU. 100% throttling means your application actually needs twice as much CPU as you're getting. So that's a very big problem. So that's it. That's the application I deployed. So the CPU we saw before. The throttling person, that means when the application is working and using one CPU, I have almost 100% throttling here. And my application is actually performing 3 million operations per second, maybe 3.2, let's say, something like that. And this application was deployed. So it's working for 5 minutes. And then it's with a certain amount of CPU. And then it's waiting and using 100 milli CPU. Okay? And the CPU limit is 1 because my application is using 1 at max. So why not set limit to 1? I'm not going above the limit. But still, I have throttling happening. Why? What's happening? So, well, I guess, like maybe let's try to increase the CPU limit, like 1.5. So now my limit is way above my usage. And when I look at the graphs, oh, I'm still using to the limit. Like I'm using 1.5 CPU now. And I'm still having throttling. But because I gave more CPU, I'm using more CPU. Now I'm doing like 4.5 million operations per second. That's better. But like if it's working better with 1.5 CPU limit, why not increase that even more? And increasing even more is why not like not set a limit at all? And what happens when you don't set a limit? Well, the CPU will give you whatever you request. Well, not your request, not the request you put in the YAML, but whatever the application needs. So the application, so applications you deploy in the system, they are always trying to get CPU to work on. Okay, they are asking the kernel, like, give me CPU, give me CPU. So this one is very hungry for the CPU. And actually, when I remove the limits, I have no throttling because no limits, no throttling. And then my application is using almost 3 CPUs here. and is now performing 8 million operations per second, twice as much than with 1.5 CPU limit. So the demonstration here is, if you think that, okay, I have to deploy this application, I'm going to set a request based on your mood at the moment, and then I'm going to set a limit because, well, you have to set a limit. You shouldn't never deploy an application, a container, without setting a limit because you're going to impact others' application in the system. Then you set a limit, you set it wrong, and your application is behaving poorly, and you absolutely don't know about it. So actually, work CPU was set to 3 since the beginning. So it was hidden because, like, at first this application is very strange because I say I want to use 3 CPU, it's using 3 CPU. But that's not how your usual application behave. Usually, your application will depend on workload, the content of the batch. You don't know exactly how many CPU it's going to use. So that's why setting limits at first, when you don't know the application, the workload, the behavior, is kind of totally crazy. If I set CPU limit to 3, then it's getting better. So then we have the without limit, and then we set CPU limit to 3. And what's happening is we're almost using the 3 CPUs that the application needs. And we have a little throttling, not much, just a little. But we're still using less CPU than the 3 of the limit, and still we can see some of the throttling here. And hopefully, on the number of operation per second, it doesn't move. Actually, I'm pretty sure it moved a little bit down, but because that's very tricky to measure, it feels it's okay. So let's say it's okay. I want 3 CPU. I set the limit to 3 CPU. Everything is okay. The throttling is still, on this previous one, the throttling is still happening because, again, the application is not using 3 CPUs straight all the time. The application is using like 4 CPU at some point, and then a little bit less. So it's actually more bumpy than that. So these bumps, they generate a little bit of throttling. So they are a little bit impacted, but at least you're using the 3 CPU that you think you need. Okay, so I introduced another variable in here. I set the because sometimes you want to cap your application, and you want to get the control exactly on what's happening. So this is more a testing, but I set CPU limit to 1, so my application should be using 1 CPU. But I set the Go max procs to 1. Go max proc is a Go variable that is a kind of a tuning of how the Go will the runtime of the application will generate threads or use the CPU. So it depends on some libraries you're using that are going to spin more or less threads depending on that value. Usually by default, the Go max proc equals the number of CPU on the node or the machine running, on the computer running the application. And that can be a problem because when your application is running as a container in Kubernetes, Go so far doesn't know about what you set as a request or a limit in the container. It only knows about what's on the system. So if you have a 32-core or 32 CPU host and you start your Go application, your application will think that it has 32 CPU to run, which is totally way bigger than what you actually gave it because you set your limit to 1. So in this circumstance, because I matched the 2 here, of course I'm going to use 1 CPU, not more, because I set it to 1. But yeah, of course, I will have some throttling. But actually, less throttling because we're not 100% throttling as we were before. And we're actually still making 6-point-something million operations per second. And still, we're using just 1 CPU. If we go back here, we were using 1 CPU, but only 3.5 million applications per second. So that's far better. And actually, this is all due of the Go tuning, which is going to spin less threads and are going to use schedule the routine in the threads differently a little bit to better use the CPU. So that's what we're seeing here. Before that, we had 3 three routine from the application. Because I said my application, I want you to use 3 CPU. It's starting 3 routine, each one consuming 1 CPU. But if we look at the threads, we had maybe like 12 here, and we're down to 6. So we cut almost half of the thread. So that's less things moving from one CPU to the other, and you get better performance because of that. And it goes like that. So now I have, like, I'm still saying use 3 CPU, but GoMax proc is 1. And I said CPU limit 2. So actually what's happening, because I set my GoMax proc to 1, actually Go will change the way it schedules things. Only 1 routine will be running at a time. So we're actually using exactly 1 CPU. And now we have no throttling because we set CPU limit 2, which is way above the usage. And we lower down to say use only 1 routine. And we're still doing like 6 point something million operation per second. So we kind of tune the application and the limits to make the system work at its best. So it's totally some kind of tuning, and there's different ways of doing that with Java, for example. The latest JVM, they know exactly how to fetch the number of CPUs from a container actually. So it kind of auto-tune, and there's packages like I think it's Uber auto procs or something like that. It's just a package you instantiate in your Go code, and it's going to grab the number of CPU from the container. It's going to compute that for you. And finally, I said like GoMax proc 1, and I unset the limits. And what you see here is I'm still using 1 CPU, and I have no throttling because no limit. And I'm doing 6 point something million operation per second. So I have the full power of the application with 1 thread running, even if I'm requesting for 3 CPUs. So the conclusion here, the first conclusion is you don't need limits at first. So try to run your application without limits, even on production, or do canary. Have 1 with the limits, 1 without. And try to understand exactly the pattern, the CPU usage of your application. And if you can, don't set limits. And this is very controversial. But set the request right. Because request, again, is guaranteed. So if you request, let's say, 1 CPU, and your application uses 2, no problem, you still can. Okay? If your application uses 1 CPU most of the time, but sometimes 2, well, set 2 as a request, okay? The drawback of that is you're going to lose, when you're only using 1 CPU but you requested 2, you're going to lose 1 CPU that is not used. It feels it's not used. And Kubernetes doesn't over-provision on CPU. So if you set your application, like we have 10 applications, 1 CPU or 2 CPU each, and you're up to the maximum number of CPU that's on the node, Kubernetes is not going to schedule new pods on the node. So actually, you requested something you don't use, but nobody else can use. But if one of the workload on the node is using more than the 2 CPU you requested, let's say 3 or 4, there's room for it, okay? And usually people are afraid of noisy neighbor. So one application going crazy, taking all the CPU on the node. And if you don't set limit, your application is going to be constrained and don't have any CPU because you set the limit too high for others and they're using it all. That's wrong. Stop thinking like that. If your application requested 2 CPU, it's guaranteed. If it's not used, it's going to be given to another application that uses more. But if your application starts working and needs the 2 CPU, it's going to get it. And the other one is going to be throttled to accommodate the one who needs the 2 CPU. So that's how it's working underneath, and that's why you shouldn't set limits. But be careful. When you don't set limits, what may happen is you're going to consume more than your request, and you don't have limits, and you get elected as a candidate, because when there is no more available CPU time on the node, the system may decide like, okay, I don't have enough CPU, I need to kill this, or I need to kill someone out, to kick out someone off the node. And if you don't have limits set, you get kind of the first candidate to be kicked off the node. So be mindful of that. Again, my recommendation is somewhere in between, don't set limits, and set limits once you know your workload. So start without limit, see how it behaves, and at some point add them, but add a value that, and again, track the throttling. Be mindful, have observability, and use it to track that down, have dashboards, have alerting maybe on throttling. Everything that is above 0 is a concern. So if it's like 1, 2, 3%, maybe there's nothing to do. Maybe you can tweak a little bit something, ensure that the GoMax proc or something like that is set. But everything that is, let's say, beyond 10% or more than that needs your attention. You need to change the values. So again, remove the limits, see exactly how it's behaving, set the request accordingly, and then put back the limit. So I have some slides for the request. It's technical, like how it's computed, how the system divides the number of CPUs, and because there's 3 different kind of applications actually running, which are the best effort, the guarantee, and the burstable. So if you set nothing, it's best effort. So again, you're going to be the first candidate to be kicked out the node if there's a constraint on the CPU or something. The guarantee is request equal limits. So you get what you requested, no more, no less. And the other one, which is usually what we have, it's the burstable. And again, burstable, because it's a total quota, so the total number of time on the CPU minus 2 plus x, which depends on, I don't remember. So it's a complicated computation. But that means the final equation here is you're going to get a share of CPU that is, again, guaranteed. And that's this mechanism that makes it guaranteed. So you're never, if you need it, you're going to get it up to what you requested. So if you're using 1 CPU, maybe you should request 1.2, 1.3, 1.5 maybe, depending on how bursty your application may be. So how does it relate to HPA? And that's the end of the presentation. So HPA, by default, so horizontal pod autoscaler, you use metrics. So, and you say, if this matrix goes beyond that, just scale the number of pods. And by default, it's using the CPU, but it's using the CPU requested. So the usage versus the number of CPU requested. And what we saw in the before graphs is that my application was using 1 CPU, okay? So if you base your HPA on that number, you're going to see that the application is using 1 CPU, and then you need to scale or not. But actually, the application is not using 1 CPU. The application is constrained down, it's throttled to use 1 CPU. The application is using 3 CPUs. So you're going to scale on something that is badly defined at the source. So be sure of understanding how exactly your application needs to work. And maybe another solution is based your HPA on something else. Maybe the metrics, the CPU use versus the limit, because maybe the limit is set too low. So in this case, you're going to scale way before, you're going to scale when you need it and not when you're constrained and actually not performing enough. So that's one way of doing it. So I have on the slides, so the slides are going to be shared. There is some Prometheus queries for graphing the throttling rate and mean. So the mean is cool to have, but the rate is more what's happening at this time. So every time the rate of throttling is not 0, you have a problem. The pod is being constrained down. And so you can graph the pod's usage that is close to the limit. So if you're using very close to the limit, that means you should increase the limit. And the CPU overcommit in the cluster. So because usually we want to stack the cluster, the nodes as much as possible, so we get what we paid for. And we want to use everything. But so it's good to track down, because maybe you're like, you think you're getting back your money when you stack the thing and use 100% of the CPU of the nodes. But sometimes you actually throttle your application so much that you could have half of the pods, half of the nodes, and have the same throughput in the end. So be sure to check these kind of things. And then there's a lot of documentation, better explanation of how all that is working, better than my talk, actually. So, and my talk is based on things I read on internet and whatnot. So there is a full list in here. Join us in our meetup, CNCF and Kubernetes meetup in Canada if you're there. Even if you're not there, we're very open when it's online. When it's in person, you can still come to see us in Canada. We love you all.
Okay, thank you, Sebastian. We haven't got any time for questions, I'm afraid, because we have a 15-minute coffee break now before we're back in this room for the last session of the day at 4:30. today for room 2. Come in, come in. It's lightning talks after this one. I believe they're all in room 1. Well done for making it to the end. We haven't even started KubeCon yet. So, in line with our new room 2 tradition, I'd like everyone to give a standing ovation to our last room 2 speaker of Cloud Native Rejekts 2023. And Faika Ansari. Thank you.
Okay. Hi, everyone. So first thing I would like to ask, it's an Indian terminology, how's the Josh? Like, how's the enthusiasm at the end of the day? I really love that. So, hi, I'm Faika Ansari. Today my talk is basically on cracking the communication puzzle in open source communities. And open source communities specifically under CNCF. So this is going to be our agenda for today. That is, I would be covering 10 really cool topics. It won't be very complicated. It will be starting from like beginner level. And I would take you through what exactly I have learned across my journey in CNCF. From how the communication platforms work, what methodologies do they use for cracking and for making collaboration more easier, and how is content managed in these communities, how is social media helping open source communities, plus turning the chaos in big projects like Kubernetes and Linux kernel into collaboration, into very healthy collaboration, successful. So all these things, from evolution of the tools that we've been using and some simple case studies that I'll be covering in today's session. Talking about this, well, it's obviously important to know me. So I'm Faika Ansari, and I am doing a couple of things in Cloud Native, from being the Kubernetes v1.29 release shadow, and being a Linux Foundation intern or mentee under Istio Mesh, which is again a CNCF project. And I'm specifically contributing to Ambient Mesh. So if someone here is from solo.io or contributes to Istio, I'd be really, really happy to meet with you all and talk more about it. And I'm also Linux, not Linux exactly, sorry. Last week in Kubernetes development newsletters author and admin, one of the admins. Plus, I think that's pretty much my introduction. I also do upstream community work, like being a GitHub campus expert and Google Developer Student Lead and Microsoft Learn Student Ambassador and stuff around. So I'm also a beginner, like I'm not very advanced person in Cloud Native field, but I'm learning, and I'm super excited to meet you all here, because maybe, not maybe, obviously, I have lots of folks here that I will be learning from. And I am really thankful to Cloud Native Rejekts, obviously, for giving me this opportunity to be here on the stage and talk about myself and my learnings. So moving forward. Yes, my first thing is effective communication. So I believe effective communication is really crucial for any community. And when it comes to open source projects, it's obviously even more important. So when the contributors like us are contributing to communicate with these things effectively, they can actually collaborate on the projects more effectively. So when you know how to communicate in an open source project, that is where collaboration begins. And to effectively collaborate, these projects, these open source projects, needs to have quality settings in order to have these things implemented. So that's what I want to talk about today. Now, communicating effectively in any open source community is not that easy, right? So contributors come from all over the world with different languages, with different time zones, and they want to contribute on the same page. So we need a really good system to handle all these complex involvements in the open source projects and all these different tasks. So that is what is today's topic, and that is where right communication platform and methods comes in. By choosing the right tools and using them effectively, these open source communities can overcome the challenges that folks face in communicating in these big organizations. So that is one thing. And the goal of all the open source communities for communication should obviously be, like I listed like here, like facilitating the collaboration and collaboration obviously, because open source communities rely totally upon collaboration. And to develop and maintain the software, it is very important that there is effective collaboration in these softwares. And yes, it is obviously essential for all the contributions to work together effectively. Secondly, there has to be engagement, which is again another goals of these platforms. Like open source communities are more than just groups of people working on a software. So these open source communities are like, what do you call it, a social community where people can not just work together, but they also connect. So that's what we actually plan to help build a strong and engaged community. That is one of the goals. So I'll just quickly list down the goals here, which is promoting transparency in these communities. From effective communication, open source community really values transparency in their work and obviously accountability. Now what do we mean by accountability is we want to ensure that all the collaborations have a voice in a community. So that's one of the things which any of the open source project needs to make sure of, and hence all the decisions should be made in a very transparent manner. So this was just some of the goals that open source projects generally have in terms of communication. And we will see how huge open source communities like Linux kernel or Kubernetes are tackling these goals and making us collaborate so effectively to these communities. So I've listed some communication platforms, like we've been using mailing lists, Slack, Discord, and several other things, and certain methods that we've been listing here. But what is important to us is the #1 rule to be a part of these community as a contributor is to participate in the open source community, and that is where it all begins. And then secondly, we start with the proven examples that I was about to talk about. So who haven't heard about Kubernetes here? Almost all of us. So it would be funny if I ask that at the Cloud Native Rejekts. So it'd be, if in case somebody doesn't knows about it and it's new to Cloud Native, I would be really, really happy to help, because that's something I would actually have my expertise in. So I would love to talk with you all in case not. So every one of us knows about Kubernetes, right? Because it is the second largest OS, and how do they manage their community? This is the second largest open source organization, I would say. How do they manage their communication specifically? So they have several settings like SIGs and subprojects, GitHub, mailing list, and events and meetups. So if we come across this, one second. To access it. Yeah, so all of us knows about Kubernetes, obviously, because it is the second largest open source organizations. Now, how do they manage their communications and collaboration so effectively? So talking about it, well, it does have 4 really cool things that is done like really well, starting with SIGs and sub-projects. So Kubernetes entirely is divided into a number of SIGs from search. So it has special interest groups and sub-projects, which is, and each of these sub-projects has its own leads and an entire team who work on the documentation, its code side, and other resources. So these SIGs really help to manage the whole open source software as well as the communication between these teams are very effective. So it is just like managing several services and the communication between those services, just what Istio does. So it's similar to what SIG does in Kubernetes. Secondly, the GitHub. So Kubernetes project is completely hosted on GitHub, like we know, where all the code and documentation is stored. And GitHub provides a number of features that makes it really easy to manage the content, be it from the PRs or the issues or managing the automations, tracking stuff, tracking the branches, making the collaborations much more easier. So Kubernetes also have several roles at GitHub, like be it the admin role or maintainer's role, reviewer's role. All these things makes it very easy for folks like us who are beginners who wants to contribute to know their role in Kubernetes and effectively communicate with the roles, like the leads or the reviewers, that ways. Then Kubernetes also hosts events and meetups, which is another asynchronous way of meeting with folks, connecting with them throughout the year, be it at KubeCon NA or Europe or cities around the countries and globe. So these events also provides an opportunity for effective communication to meet in person and also learn from each other. Similarly, mailing lists and Slacks, I would say. Kubernetes uses a number of mailing systems and collaborations that these channels are used to discuss new features, ask questions, so many things around. So this is one of the way Kubernetes, four of the ways, that Kubernetes is using to troubleshoot their communication problems in the community. It doesn't end here. This is just lovely communication way. We are just trying to learn from the leaders and how Kubernetes is managing their communication problems. So it uses a number of tools and resources. It's not doing it all by itself, it's the software, right? So, one second. So this is Kubernetes documentation. Talking about first, what we learned from Kubernetes is the documentation itself. So Kubernetes documentation is like a really comprehensive guide that Kubernetes uses, and it covers all the aspects of the project, be it from the code part or understanding the release notes and everything. So the community is upgrading and updating all these documentations regularly, and that is all done via Kubernetes documentations team. It has an entire team that is handling the docs. Similarly, Kubernetes has a blogs team. So the blog is used to publish the news in Kubernetes about the projects and stuff, just like I have also been a contributor to Kubernetes blogs at several times. So there are contributors coming from different places and they want to contribute effectively to these blogs where they get a voice. They can get to voice their opinions, they get to voice their foundings in Kubernetes. We have several blogs like 6 Spotlight blogs to name a few. So what we do at 6 Spotlight blogs is we basically just give a spotlight to some good contributors in Kubernetes. We talk about them in our blog. So this is how the communication is managed in blogs. We convey our needs, we convey our docs, we convey our solutions through blog writing. Similarly, Kubernetes social media, it has lots of social media platforms it manages, Twitter, and it's also managing its website and stuff. So that's how communication is managed in Kubernetes community, where the communication is obviously great. Okay. Now, since the last part of it is turning chaos into collaboration, that's one of the part of agenda today. So we have seen that establishing a clear guideline and for code of conduct and all those things is not that easy once. Yeah. So there's a lot of chaos that comes handy when we talk about large open source communities. So turning this chaos in open source projects into collaboration is one of the goals of such projects. And that is why we are going to discuss some proven techniques and strategies that these communities are using to tackle these things. starting with establishing a clear communication guideline and code of conduct for all the community members like I've written. So we need to ensure that there are clear guidelines mentioned for the ones who want to communicate in the community, who want to begin communicating or network in the community. So there has to be a structured guideline for the same. There needs to be structured meetings. So if I talk about myself, when I was starting off in open source community, the meetings was one of the way I got involved through. So we need really good structured meetings with defined agendas, with defined facilitators. This will prevent the meetings from becoming a lot chaotic, and this ensures that the discussions are very focused. So this is one of the way Kubernetes handles its chaos. That is, it has structured meetings. It has meetings for each and every SIG, and it has leaders who handles it. So they have facilitators for each of these SIGs and domains, which makes it a lot less chaotic. Then we have collaboration tools. Now, what do we mean by collaboration tool is Kubernetes in itself utilizes a lot of collaboration tools like project management softwares and issue tracking systems. Then it comes from instant messaging platforms like Slack. Then it also streamlines the communication and project organization. We have meetings on Zoom calls and stuff like that. So we're using several tools for managing several things. The most important aspect, like I spoke of earlier, is transparency. So Kubernetes is one of the most transparent organizations that I've been a part of. Everything that happens here has been transparent, and I've seen them emphasizing to the importance of transparency in even decision making. So they share like reasoning behind all the decisions that they make in the community, and it involves a lot of discussions in the community. How does that happen? We have regular mailing list through which the discussions is happening. We have polls going on, and we take regular votings and stuff, which is all very transparent. So that's how a community becomes way less chaotic. It's not just anyone randomly taking decisions. There is a lot of mentoring and onboarding in Kubernetes. Regularly, every day, new folks join in Kubernetes organization. They want a mentorship and stuff, and they have their support through the Slack channels, or be it GitHub issue or whatever, or through the meetings. So they have developed that mentoring and onboarding programs to help new contributors to come together and smoothly contribute to these projects. And this definitely reduces a lot of confusion in this organization. Then coming to document and knowledge sharing, we also obviously at Kubernetes prioritize the creation and maintenance of comprehensive documentation. So from blogs to having guidelines to user guides and everything, the knowledge is shared and is accessible to all the users through GitHub and several other platforms. That's one thing. There is a feedback mechanism, which is one of my favorite. It has a feedback mechanism where all the community members have a voice. They can provide their input, they can report their issues and improvements, everything in a very structured manner. There is an issue system and everything. So that's one of the ways they have tackled their chaotic communication problems. There is role decisions that is made at this organization that I've seen. It defines the roles very clearly. It has the responsibilities divided, and all of that is mentioned on a README Markdown file on GitHub. So that's how communication is managed. It is ensuring that everyone understands what their role is in the entire collaboration process. Then there is inclusive decision making. Kubernetes as an organization have promoted inclusivity in its decision making, it gives voices and perspectives, ensures that all the decisions are made collectively and not by a single entity. So that's one of the things. We have scheduled works and scheduled sessions for all the time zones. We keep that in mind. We emphasize the importance of transparency. These are several things that Kubernetes keeps in mind and has a lot for us to learn from when we manage our own community or open source project. It could be anything. So these are some simple things that we can learn from Kubernetes and other CNCF organizations that are doing really great today on how they manage their chaotic schedule and promote so much of collaboration. Yeah. Now, moving ahead. Talking about inclusive communication. So, like I said already, understanding diverse audiences is very important, And I really believe Kubernetes have actually handled that really well, since I have only 5 minutes and I have several case studies to share as well.
You can have 10 minutes.
Okay. So I'll try to. By emphasizing the importance of understanding diverse backgrounds, experiences, and stuff, Kubernetes is doing a great job with it. I'm really sorry if my voice is lacking. I actually have a jet lag. I traveled right in the morning, having a slight headache, but yeah, I'm trying my best. And I really appreciate the happy faces. Yeah. So about inclusive communication, we have multilingual support in Kubernetes that comes in. So you see people from different countries coming together. They are even helping Kubernetes with converting the language of the GitHub documentations. It discusses the benefits of providing content in multiple languages. It makes communication so much easier. So that's one of the ways we really learn how inclusivity is managed in Kubernetes, not just in Kubernetes, but in any of the flourishing open source organizations. They have their own accessibility standards. So what we mean by this is they emphasize the importance of following accessibility standards to make sure that the content is usable by individuals with disabilities as well. So that's one thing that Kubernetes is handling, and I was a part of GitHub Campus Expert, like I said. I've seen them as an organization also handle these standards. These are the things that makes a community really, really collaborative, and that is how communication struggles are actually tackled in a community. So when we include these things, such as like those screen readers and stuff, that's pretty helpful. Then we have inclusive language. Kubernetes and other organizations also promote the use of inclusive language and code of conducts. There is diversity in leadership positions, like I spoke about Release Shadow program that I was a part of in Kubernetes. We have diversity in the leadership roles. We make sure that our team has people from all, like at least different regions, different genders, different diverse categories. So that is how Kubernetes is also, not Kubernetes only, I don't know why I'm just saying Kubernetes. I want to talk about all the flourishing open source organizations that have tackled the communication problems in their organizations. So these organizations have committed to diversity in leadership. So this is one thing, and that is one reason that you see an organization so much famous and so much spoken about. So this is one thing. Apart from this, cultural sensitivity. Now, we obviously at Kubernetes and other organizations value everyone and encourage everyone for respectful of their cultures and their traditions. A good example of which would be, okay, I'm not having one in my mind right now, but yeah. So we definitely try to prohibit discrimination and stuff at Kubernetes and open source organization to tackle these problems. I have spoke about feedback mechanism which we have and which actually facilitates the inclusive communication. And that's how we see the evolution of communication tools. So in these organizations, we've seen a huge evolution from, initially we used to use mails and mailing lists. So the global communication was enabled and collaboration used to happen through mailing lists. In the late 1990s, there was, because of the geographical boundaries and stuff, the open and inclusive discussion used to happen through mailing lists only. But then in the mid 2000s, I guess we switched to SVN and Git. And now from mid 2010s, we are using Slack, Zoom calls, and Discord as a platform. So this is how communication tools have evolved, and speed and performance have also increased, obviously. Like the Git speed and performance was advantageous for projects of all sizes. It reduced a lot of latency in the development workflows, and it improved a lot of productivity. Plus, the impact of GitHub as well was closely tied to the platforms like Git, and it also revolutionized the whole open source collaboration thing. So these are some of the things that really helped in tackling the communication struggles in open source projects. Yeah, and these were some previously used strategies, like some examples of strategies that is used by Linux kernel community, Mozilla Foundation, and OpenStack community, which are really flourishing right now. starting with Linux kernel community. They have their own mailing list. So this community basically uses a mailing list as a primary communication platform, which allows developers to discuss the ideas, the purpose changes, and also review the patches. So the mailing list is like open to everyone and who wants to participate, and it is archived for easy reference. Similarly, there are regular releases in the Linux kernel community, and how the community releases a new version of the kernel every few months, and this also allows developers to plan their work accordingly and ensures that a new feature and the bug fixes are delivered to users in a very timely manner. Then Linux kernel community also has like really clear documentation. So it maintains a very clear and comprehensive documentation that really helps developers understand how they want to contribute to it. Understanding from Mozilla Foundation, they have their blogging system. So basically they share their updates on its projects and community events and other news through blogs. The blog is like open to comments and allowing readers to engage with Mozilla staff and each other. They have social media pages where they have like a really strong presence. Mozilla has a really strong presence on social media, specifically on Twitter and Facebook. And they use these platforms to share their news updates and engage with its community. They also have community events happening where they organize events such as conferences and workshops, which makes it very easy. So this is some of the booming facts about Mozilla Foundation, and then comes open source communities, OpenStack community, sorry, which have its own forums, forums that it uses as its primary mode of communication. And it also have user groups like we have in Kubernetes, that is special interest groups. This community has user groups in various regions around the world, and these groups are basically providing a platform for community members to meet and collaborate. And yeah, they have really good documentation. So that was about the case study and about the growth of Linux, the growth of Kubernetes, and the role of communication in open source companies. So about the growth of Linux, I guess I've already spoken of it. That is, Linus Torvalds effectively communicated with the open source community to build one of the most widely used operating system, that is Linux, in the world. Through several strategies, they started using open mailing lists, they had a clear vision, and obviously an inclusive approach, and a revision control system. So that's one thing. With constructive criticism, and that's what we learned from the Linux community. Coming to the growth of Kubernetes, it's again the same. The initial development was open sourced by Google in 2014, and this obviously allowed the developers and the community to collaborate more effectively. That's one thing for us to learn, how the communication became so easier in Kubernetes after it moved separately and facilitated the rapid development and improvements. So the community adoption of Kubernetes also gained like quick adoption rule to its flexible and robust container orchestration rules. So that's something. Plus Kubernetes has a really cool ecosystem expansion, I would say, like an extensive expansion of the tools and services that Kubernetes uses, including the Helm for package management, or Prometheus for tracking and monitoring, and Istio for service mesh. So all these things further enhances its appeal. It also meets the industry standards, and it's also CNCF governed. So that was one thing. And we saw the role of communication in open source communities and companies, the community engagements and stuff. So in conclusion, I would suggest the 4 common to Bs to be a part of it. Be clear and concise. Avoid using jargons in open source community. Be very clear when you are communicating with people through GitHub or whatever. Be active, be respectful, inclusive, and be willing to help others, because that's how we all grow. And I guess that's where I am here, and looking forward to speak with you all. Thank you so much.
Bang on time. Well done. Fantastic. Okay, so that was the last talk of Room 2 for this year's Cloud Native Rejekts. The remaining talks will be the lightning talks in Room 1. So one more, please, standing ovation for our final speaker, Faika.
Get out.
And please, a round of applause for yourselves. You've been a fantastic audience.